Good afternoon, sir.
Yeah, good afternoon, everyone. Good afternoon, Professor Satyajit. Am I audible clearly?
Yes, sir, you are audible and
Okay.
visible both.
Yeah, thank you. So,
Farhan, please.
so shall we wait for some couple of participants? They are joining.
No, sir, you may start. Farhan, please.
Thank you very much, everyone. And thank you, Organizing Institute, Professor Satyajit and his team for conducting this valuable program, short-term training program on research methodology. So special thanks to the advisory committee chairperson, Professor Indraleen Mana, who is the vice chancellor of BIT Ranchi. So it's a great opportunity. Thank you very much for from my side, from my institute, for and congratulating to you as well. So it's a wonderful program which you have conceptualized in this, and I'm happy to share my experience on the topic allocated to me by the committee, that is on analysis of variance techniques and factor analysis. So though it is a basic program, so I will try my best to give you some insights like what are the bases, how and we can use these techniques, which are the scenarios, because whenever analysis come into picture these days, research scholars are working on the theme. So before going to the start, I would like to interact with the participants because it will help me to give the example related to their area. So it may be useful for them. Maybe it's a interaction of 2 to 3 minutes. Am I audible, participants? So I welcome you all in this session. You can
Yes,
open
sir.
your camera and you can open your mic, unmute your mic and camera, and you can discuss. Yes, Miss Nivedita, you have something to share? Because interaction is good, because without interaction we can't be synced actually from your side and my side. So I'm just always trying, not in this session, various other sessions, to come up, because I am not familiar about your areas. But basic idea is that you are researchers, you are doing PhD, or you have done PhD. Those who have done PhD, they are writing some research papers, they are publishing, and they have some stigma, because we all have stigma in our research life, that okay, which methodology we have to use and like this. Yes, guys, quickly, so that we can start our session. Maybe or one or two, maybe one or two. Nivedita, you have something to share?
Sir, I'm a research scholar.
Okay.
Yes, sir.
Okay, what area you are working with?
Sir, I'm a mathematics student and I'm working in the field of cyber attack and cyber defense.
Okay, cyber defense. Okay. So your enrollment is with the management or mathematics department?
So mathematics.
Mathematics, right. Okay, thank you. Yes, any other? Because it is good to have the areas so that I can try my best to give you the example from your area. Yes, Farhan, G. Malik, Vandana, Kunal Sinha, Bhageshri Pandey, Dr. Bhageshri Pandey, Priya Parol, Divya, Parveen Zahara. I'm sure you are with me, guys. Dr. Satrajit.
Yes, sir.
Yeah, are they comfortable in interaction, or it is one side,
So it will be a mix.
though the sample is very small. Yes, Kunal.
Yes, sir. Good afternoon,
Yeah,
sir.
good afternoon. Yeah, what area you are working with? It is good to interact now because it's an opportunity.
Basically, my domain area is marketing,
Very good.
and I am
Marketing.
assistant professor in GLA University, Mathura.
Acha, Mathura. Okay, very good. My hometown is in Agra. I belongs to
Okay,
Agra.
okay.
Yeah,
Very good.
very good.
Basically, I belong to BIT Lalpur. I am the student of BIT Lalpur. I
Okay,
did
very
my
good.
PhD from BIT Lalpur itself only,
Very
under
good.
the
Very good.
guidance of Dr.
Congratulations.
S.L. Sadeh, sir.
So mostly all people are from BIT or from different parts of the country? Because I was expecting more participants actually, but since it's a lunchtime, maybe they join. So thank you, Dr. Kunal,
Okay, thank you, sir.
for sharing the area. Any other participant who would like to add and interact? Priya Parul, Divya, Amitabh. What is the need of factor analysis? Anyone in the class? Why we are doing? Why the world is moving towards these critical analysis these days? Every time 1 2 analysis softwares are coming. So what is the rationality behind? Anyone in the class? Divya, Amitabh, Parveen, Arunima. I'm sure you guys are using these techniques.
Sir, when we are choosing the topic of PhD, so
Ji.
we must be very much alert that how the PhD topic must be related to the research work. So sometimes the guides create problem. No, the topic must be in this way. So please give us some guidelines regarding this.
Sir, Amitabh ji, actually the techniques has nothing to do with the area of research. I can give you because any problem can be a good problem. But the problem where we researchers stuck up is that sometimes the data is not supporting the analysis. There are
Very
certain
good.
analysis which is required for this, where the guide will help you, but sometimes guide is also not aware these days because there
Yes.
are multiple problems. But I will tell you one thing, sir. uh, as far as the management, mathematics, or the other areas, even engineering
Yes, sir.
also,
Yes, sir.
most people are working and likely to be work in the area of multivariate data analysis. So
Yes, sir.
multivariate data analysis, is quite, I should say, it's quite vibrant, where these techniques are there, like factor analysis,
Yes,
CFA,
sir.
EFA, under which circumstances. So we are going deeper and deeper of the section because I will give you some examples also in between. So it is nothing to with the title or the topic in which area. Everywhere you apply these techniques. Even I will tell you one thing, which is great also. Apart from these techniques, also you can publish paper. You can do research with the help of case study method. Case study method is also area which is more qualitative, not quantitative. It is more qualitative. You
Yes.
can still
Yes.
protect the problem, yeah, but you
Yes.
should be familiar enough. I provide training also on case analysis. Even last month also provided to ISTD training program. So it is like that. It's your choice. It is not like everybody is a scientific temperament, like everyone should know these techniques. That is my way. But once you are doing with, you should be familiar enough with the statistics and all.
Yes, sir. Yes, sir.
So title has nothing to do, area has nothing to do. These are the tools which you are comfortable. You should apply what is required when it is required because it will give you more conclusion. A
Yes.
more, or you can say it is a right way to represent your results.
Yes, sir.
G. So you are working in
Thank you.
marketing area, sir?
No, HR area.
HRAD. Very good.
Yes.
Thank you. So guys, let's start. I think thank you very much, participants, for this. I'm sharing the screen, and please be ready with your notepad because some of the information you may be interested to find. Please mute your mic also if some sounds is coming.
Yes, sir.
I'm sure the screen is visible to everyone. Is it okay? My screen is visible to all the participants.
No, it's not visible right now.
Maybe some connection problem at your end. Anyone please confirm in the chat window. Please use chat window also.
No, see, it's not visible.
Now it is okay.
So we can see only this Google Meet screen only. We are unable to see your.
Yeah, Google Meet screen only. I'm confirming.
Yes.
Yeah.
That is
Okay. Thank you.
visible.
Yeah. Thank you, ma'am. So now it is okay.
Yes.
Yes.
Thank you.
Yes.
Thank you. So guys, it's a great attempt from the institute. I still remember Dr. Satrajit was discussing this concept, I think last year, if I'm not wrong. He was planning to, and now the time has come. So I hope you had a good training. So I'm your facilitator, Rudra, for today's afternoon session, and tomorrow also I have another session. And it is a 5th day program, and tomorrow this entire STP is going to over. So I'm the lucky one to wind up your this STTP, because tomorrow may be the last session of mine. So you have the 2 session, and I will share my email ID with you, with each and everything. If you have any query, I will address tomorrow also. So it's an opportunity for all the participants to come forward. So thank you, one and all, for your kind attention in this STPP event. Hope you had a great learning on diverse topic of this event, which you have covered already, right? So in that line, so journey thereafter, so my topic is analysis of variance techniques and factor analysis. So analysis of various techniques, please understand though, because I have seen many people, they are not familiar. What is ANOVA? What is variance? What is the need? So that is so. I just started even just 2-3 hours before when Dr. Satrajit was called up me and asking. So I was preparing this thing because I always look at from the basic to the advanced, so that is the flow always I keep. So analysis of variance is the full form of ANOVA. So any people, it is a researcher's language, ANOVA. So analysis of variance is there. So variance, what is variance, what is analysis. So in a statistical term, it is a method that divides observed variance data into different components. Any different components, I will give you the example also, but this is the statistical definition. It is a statistical method. So you can say that there are different statistics in management sciences, in engineering sciences, in pure sciences, applied sciences. Statistical methods are quite useful, these days, because it will give you these analysis up to the mark. But these days, another sad part is that, which I would like to share with you. Every people, they are using all the test. I review some thesis also. So now the examiner will decide, okay, whatever you want, you just check it. Okay, so that scenario is there. So people are randomly using these techniques because all these techniques are governed by the softwares. So they just select all these things, and they give the result, and they interpret the result, but without having sense. So that is a lacuna of the researcher's part, and due to which 75 to 80% of the research papers are returned on the spot by the editors, because they are not giving any new idea, new analogy behind. So that's why I'm important. So I will give you some scenarios also in between. So it's a statistical method which separates observed variance data into different components. Components could be X, Y, Z, X1, X2, X3, X4, X5, X9. So if one was used for more 4 times, so the popular test is one-way ANOVA, another is two-way ANOVA, right? So the popular one is a one-way ANOVA, It is used for 3 or more, 4 times groups of data. Groups of data, because if you have the data, you have different groups also, in order to have some information about the relationship between dependent variable. So it is always been the dialogue, as I've started the discussion with multivariate analysis. So, guys, what is the beauty why the researchers are working these days in multivariate data analysis? Because in multivariate data analysis helps you to understand about the you means you need not to choose any, like what is dependent, what is independent, because in multivariate data analysis both these IVs and DVs, these you can see here, DVs and IVs. DV is a dependent variable, independent variable is IV, right? So don't be confused. DV is a dependent variable, IV is a independent variable. So both these variables work simultaneously in the category of. Otherwise, if you go to bivariate analysis where two variables are, a univariate analysis only one variable is functional. So under those circumstances, when the computer was not there, people were working on one variate analysis or maximum at the bivariate analysis, and they face a lot of problem, like what is a dependent variable, what is your independent variable of your study. But when these tools came, these analysis came, like the softwares like SPSS, R, Edinco, Minitab, various softwares are there, right? I generally provide trainings also, but since this is a basic session, so I'm just giving you the idea of what is the basis actually. So I'm just trying to facilitate what is the basis, why people are doing it, based on, because in this case, dependent and dependent variables are working simultaneously, right? In this way. So that's why ANOVA, factor analysis. So these are the part of factor analysis, certainly a part of multivariate analysis where we are dealing with the different variable. Multi means different variables. We have to choose as per the context related to that. So that is the idea. And whenever we have the data, our data is segmented and fragmented into groups. So when we have the different groups of data, about like say 3 or more than 3, so one-way ANOVA is technique is recommended. This is for some basic idea, right? So you can see this chart. It is an interesting chart. You will take the pic also. You can click the pic also. I found it very useful in the training programs like this. ANOVA, one-way ANOVA, two-way ANOVA, three-way ANOVA. So here you can see one-way ANOVA is effect of one variable to the other variable. It is one variable is active. Please understand, one way is one variable is active. But what is the example of the second two-way ANOVA? Effect of age and session on BMI. Suppose effect of age, like your effect of age is going on your employment. I'm just giving the other example which you can easily correlate. Effect of your age is going on your employment, and another your effect is going on the profitability, means profits. Like after your job, will you be profitable or not? So that is the idea. So where you are dealing with the two variables simultaneously, this and this on this. So two variables, effect of age, effect of profitability on your employment or employability. You can reverse also. It depends upon your choice. So you can see one-way ANOVA, it has the only one variable is active. That is connected with the one-way ANOVA. The two variable is active, in this case, two-way ANOVA. But here you can see three-way ANOVA, effect of age, SES, diet, or anything, like you can say your clothes, type of clothes, anything you can go with it. BMI is nothing but you can take anything like profits, like profitability. So you can interchange the variable also. So if you see, by and large, one-way ANOVA is dealing with the one variable. Please understand. Otherwise, many people confuse, sir, why we choose, how we choose this thing. It has connection with your variable of main variable of your study. Okay, I hope it is clear to you. So two-way ANOVA is effect of age and some other variable on something else, on the third variable, right? And three-way ANOVA is effect of impact. Many people say impact, many people say effect. So both are things there. And research is what? To know this effect, how much this effect is there. एक वेरिएबल का दूसरे वेरिएबल पे कितना इम्पैक्ट है, that we are trying to measure it, right? So one-way ANOVA, two-way ANOVA, three-way ANOVA. So ANOVA with repeated measures, comparing means like we compare like A to B, B to C, comparison, That is in Hindi we call Tulnatmak Adhyan, that is comparative study, right? So it is comparing more than 3 or greater than 3 group means where the participants are same in each group. That is the example. Example, you can say group of subject is measured more than twice generally over a period of time. I will give you another example because you all are belongs to academics. Suppose someone asks me or your dean asks you, you are the teacher and you are teaching some classes, your dean asks you, may I know the impact of or the effect of your teaching on the mindset of the student? Mindset of the student. So mindset of the student is at the place of VMI, effect of your teaching skills, maybe your teaching style on on the mindset of the student. So that you can consider one way ANOVA. Impact of or effect of your teaching styles and skills. Skills. I'm adding another variable. Skills on the mindset of the student. So it is the example of two-way. And effect of age, like in my example, effect of skills, teaching style, and motivation on the mindset of the student. So here you can see in the 3-way ANOVA, we are choosing 3 variables. One is the, what is that? Can anyone, you can type in the chat window also. So one is the skills, motivation, and style, right? On the mindset of the student. So if you get 3 variables, apply 3-way ANOVA. If you have the 2 variable, apply 2-way ANOVA. So these options are available in your software. You choose, select, and then. So this is the root cause where people are not getting, they are confused sometimes. They said directly, blindly they are applying. No, it is not the case, because these are 3 different situations of the ANOVA, right? Rest is okay. So what is ANOVA? Explain it. So I have prepared this presentation in the form of some questions sometime on the concepts also. So ANOVA explains in a suitable example. In layman also, I have tried to give you some examples like this. So ANOVA tells you if the dependent variable changes. Dependent variable, why we call dependent? Because everything is dependent on or over that variable. If the dependent variable changes according to the level of independent variable. Independent variable is free, you can say. Nothing is binding. But dependent variable, everything is binding on that. So that is the simple way, as name explained. If you agree, dependent means you like son and daughter are dependent on your mother and father. But father and mother, they are the independent variables, you can say, in any study, if you see. Like dependent variables, who are the dependent variables? Like son and daughter, maybe the kids on their parents. But the parents are not. Parents are independent variables. So for example, here you can see, it is in front of you. Your independent variable is a social media use, because social media has nothing to do with the people like you and me. Because if you and me, we will not use, still the social media will grow, right? Because new people will come, but social media is an independent variable. And you assign groups to low, medium, and high level of social media use to find out if there is a difference in hours of sleep per night or not. Because these days, many people are working on predictive analytics, social media analytics, perception analytics. So these days, whenever these pollings are there, polls like recently, these elections are over. Like so, many researchers, even multimedia houses, like news channels, what they do, they just go for the perception analysis, social media analytics through these handles like Instagram, Facebook, and all. So they just understand the general outlook of the people, like what is which party will win, like this. So you can say, so independent variable is social media use. It is a utility, right? But the other groups, it is based on the low group, medium group, high group. It depends upon and you can see similar kind of another example like fertilizers and residuals. So in this way, the result will be generated, where degree of freedom is there, sum is there, square mean is there, square values there, F values there's like, so different tests are there. So whenever you use ANOVA, F test value is recommended. F test is required. So please write it, because research has given a lot of clarity these days. So But you should know the rationale behind it. It is not like that blindly, okay, somebody said that's why I'm doing it. You should know the connection. Connection actually, I have given various talks and all, but many people, I found that they do not have any idea or very less idea, I should say, because the connection is not there. You can say the connection is missing. They are not deep rooted, or their thoughts are not deep rooted in the research. So it is really important for the researchers like you and me. We should respect these stress. Why is ANOVA test used? So generally it is a common question, maybe excuse me. This is a popular question in the research fraternity. So when we use and under which circumstances we should use, like, so I am giving you the one example also here. So the one-way analysis of variance ANOVA is used to determine, to find out whether there are any statistical significant difference between the means of two or more dependent or independent variables groups. Independent means unrelated, because they are not related, they are quite apart. Okay, so that's why we generally call it as a unrelated. जो चीज संबंधित नहीं है, जो कनेक्टेड नहीं है, दोनों चीजें अलग अलग है, दैट इज नोन एज टू और मोर इंडिपेंडेंट वेरिएबल. बिकॉज इंडिपेंडेंट आप समझ लीजिए, यू जस्ट ट्राई टू हैव द इंडिपेंडेंट मीन्स नॉट डिपेंडिंग ऑन एनीथिंग, दे आर टोटली अनरिलेटेड, राइट. ग्रुप्स मीन्स एक समूह में है, वन डेटा another data, like this. So although you tend to only see it is used when there are a minimum of 3 or rather than 2 groups. 2 ग्रुप है, 3 से ज्यादा हो सकते हैं, मिनिमम 3 होना चाहिए, because otherwise the rationality will become the problem. So ANOVA is a analysis of variance to compare the means. So what we do, this analysis will help to understand the comparison of the means between different samples. Category 1A sample, category 2 sample, then you decide, okay, which one is best, right? So this is the most basic definition of ANOVA. ANOVA is used in different places to compute different things. ANOVA का इस्तेमाल रिसर्च में कई जगह पर अलग अलग तरीके से किया जाता है, right? So that is also there. It is not a one thumb rule. ANOVA is also changes, one or two slides I have also prepared. It is just for your additional knowledge, right? So I will give you an example from a field of insurance. Insurance I think हम लोग सब कराते हैं. इंश्योरेंस आपने भी कराया होगा, तो उसी की तरफ से एग्जांपल को समझते हैं, आपको समझ में आएगा व्हाट इज ANOVA एंड हाउ इट इज देयर. So suppose a company has a 5 kind of life insurance policies. ठीक है, किसी कंपनी के पास, कोई भी कंपनी आप ले लीजिए, XYZ कंपनी, they have the 5 kinds of, 5 प्रकार के उनके पास लाइफ इंश्योरेंस पॉलिसीज है, which are A policy, B policy, C policy, D policy and E policy, right? You are the product manager. Suppose you are the product manager, or you can say you are the head of your family. Sorry, because we are giving the example from insurance company, so you can't be a head of a family, right? You are the product manager of that X company, XYZ company. मेरी company का नाम है XYZ, please note down. So you are the product manager of that company, XYZ company, and you want to know those 5. Those means 5 policies. Life insurance policy, LIP, life insurance policy, sold insurance policy. इन 5 में से कौन सी मेरी पॉलिसी सक्सेसफुल है? सक्सेसफुल in terms of have the high credibility, many customer like you and me preferring to choose life policy from XYZ company. तो जो मैनेजर है वो देखना चाहते हैं, वो पता करना चाहते हैं कि इन 5 पॉलिसी में से मेरा एक पॉलिसी कौन सा है, बेस्ट है, मोस्ट सक्सेसफुल सोल्ड इंश्योरेंस पॉलिसी, बिकने वाली पॉलिसी, सोल्ड इंश्योरेंस, राइट? सो ANOVA is used here to compute which policy has a better mean by analyzing their variances. तो हम क्या करेंगे, ANOVA को हम यूज करेंगे एंड द पॉलिसी के बारे में पता करेंगे. जब उनके वेरिएंसेस हमें पता लगेंगे तो उनका हम मीन निकाल लेंगे, बेटर मीन, और मीन से हमें पता लग जाएगा कि विच पॉलिसी हैज. तो जनरली नंबर ऑफ पार्टिसिपेंट से मत देखिए कि कितने लोगों ने पॉलिसी ली तो वो पॉलिसी अच्छी, राइट? दिस इज नॉट द करेक्ट जजमेंट, राइट, विच जनरली पीपल और रिसर्चर्स डू, कि मेरे पास रिस्पोंडेंट ज्यादा है, जिसने ज्यादा पॉलिसी लिया वो अच्छा पॉलिसी है. No, researchers always go in deep root. Number of size, number of participant is not the right judgment to take the mean, because हमें वेरिएशन ही नहीं पता. हो सकता है किसी ने उनको फोर्सफुली बोला हो या कहा हो कि आप ये पॉलिसी लीजिए, या कंपनी ने कुछ और अलग से इंसेंटिव दिया हो, मे बी यू कैन से हिडन इंसेंटिव, राइट? So researchers not always go, it is not the right approach, but generally people do and go with that approach. It is not. So that's why ANOVA is used here to compute, to analyze which policy has a better mean. जिस policy का mean अच्छा होगा, analyze their value, क्योंकि उसमें और भी factors है. जैसे factors हो सकते हैं, जैसे मैंने बताया कि maturity rate अच्छा है, interest अच्छा है, और मेच्योरिटी के साथ कुछ और गेन्स देते, बोनसेस देते हैं, यू नो. सो लाइफ इंश्योरेंस पॉलिसी डिपेंड्स ऑन नॉट ओनली द नंबर ऑफ पीपल हु हैज बाय, बट डिपेंड्स अपॉन द पीपल, डिपेंड्स अपॉन द क्वालिटी ऑफ दैट पॉलिसी. तो क्वालिटी को हम कैसे जज करेंगे? विद द हेल्प ऑफ दिस मल्टीवेरिएट एनालिसिस. सो आई होप दिस एग्जांपल विल हेल्प यू टू अंडरस्टैंड how and why ANOVA test is used to analyze. So this is just in one example. There are multiple ways how ANOVA can be used. एक और एग्जाम्पल देख लेते हैं. मेरे एक और एग्जाम्पल आपको दे रहा हूँ. लेट्स ट्राई टू अंडरस्टैंड विद वेरी बेसिक एग्जाम्पल. एक कंपनी का एग्जाम्पल लेते हैं, ई कॉमर्स कंपनी का. एंड ई कॉमर्स कंपनी रनिंग ए कैंपेन whose main motive is to find which is the most profitable channel for the company through which the customer connect and buy. एक ई कॉमर्स कंपनी है, वो कुछ कैंपेन चला रही है और उसका मोटिव क्या है, उसका गोल क्या है कि वो किसी प्रॉफिटेबल चैनल देखे कि किस से मेरे कस्टमर ज़्यादा बनते हैं, कनेक्ट होते हैं और मेरा प्रोडक्ट बाय करते हैं. ई कॉमर्स कंपनी, राइट. सो दिस इज द वन सिचुएशन. देयर आर टू चैनल्स, मोबाइल एंड इंटरनेट. तो इसमें क्या दो चैनल्स है, एक तो मोबाइल है, एक इंटरनेट है. सो दे डिड द कैंपेन बाय आस्किंग पीपल विच चैनल दे यूज फॉर शॉपिंग. तो उन्होंने कुछ कैंपेन किया. कैंपेन यू नो लाइक इवेंट when they go and they give some buy one get one free and some interaction with the customers randomly. It is a random campaign or door-to-door campaign like this, or they will fix the place and they invite. So campaign is campaign is the awareness program to understand, to find this whether the product is reachable in the market like this. Okay, so abhi aapki marketing team dekhti hai. So now the marketing team of the company want to analyze the result of campaign. Ab marketing team का काम क्या होता है? कंपनी के को बताना उसके रिजल्ट्स कैसे रहे, उसको एनालाइज करना कि whether the campaign was successful or less successful or it was a worst campaign, right? ये तीन सिचुएशन जनरली होती हैं. So they check the response rate for those who decides channels here. तो ये हमें बताएगा response rate for those two channels. For one channel there was the mobile channel and another is the internet. So here ANCOVA comes into the picture, analysis of variance, which will check which channel is better, mobile or internet. And ANOVA will also calculate the average response rate. उसका औसत निकालेगा. औसत means average, mean भी बोलते हैं, average भी बोलते हैं, but statistic term is mean. स्टैटिक टीम में हम लोग एवरेज नहीं यूज करते, उसको मीन बोलते हैं, राइट. औसत, इन हिंदी वी कॉल इट एज औसत है. रिस्पॉन्स रेट फॉर दोस हु चैनल्स, टू चैनल्स अबाउट दिस लाइक इंटरनेट एंड द फोन, मोबाइल फोन, टेल यू विच वन इज अहेड ऑफ द अदर एंड बाय व्हाट फ्रैक्शन. अब देखिए यहाँ पर एक कंडीशन ऐड हुई है, एक आगे है, जरूर एक में से एक आगे होगा, ये तो अंडरस्टूड है, बट कितना, दैट कितना इज द वेरिएंस, राइट. So what fraction that one channel is ahead from the other channel, that the ANOVA will tell you. So now assume, अब आप समझ लीजिए, उसको assume कीजिए, मान लीजिए there n number of channel, मान लीजिए बहुत सारे channels हैं, and there are multiple sources of data. कोई कहीं से आ रहा है, कोई word of mouth से आ रहा है, कोई questionnaire distribute कर रहा है, कोई internet use कर रहा है. Internet भी दो तरीके से होता है, एक offline एक online है. Online means directly you have given the link and randomly people are, generally these days Facebook is quite popular, Instagram is quite popular among the youth categories, like population is too big to do normal calculation, errors increases with big population and complex scenario. So there comes a role of inferential statistics. जब ज्यादा चैनल आएंगे, मान लीजिए यहाँ तो दो चैनल की बात है, मान लीजिए बहुत ज्यादा चैनल है, बहुत बड़े स्तर पर काम हो रहा है, लोग देखना चाहते हैं, like people want to connect with the big brands, big campaign. Not in India, forget about this one or two company, maybe larger pool of companies are participating. अब वहाँ आपको select करना है. So there you will go for the normal calculation. There you will get some errors increases with a big population and complex scenario. Complex scenario means कोई भी situation complex हो सकती है. मान लीजिए किसी का लोगों को data misplace हो गया या data randomize हो गया, डेटा किसी कंपनी का किसी कंपनी में एड ऑन हो गया या उस कंपनी का डेटा डिलीट हो गया, लाइक दिस कॉम्प्लेक्स सिचुएशन कुछ भी हो सकती है. लाइक So under those circumstances, उन गतिविधियों में, उन परिस्थितियों में, so there comes the role of inferential statistics. इसको आप नोट कर लीजिए. Inferential statistics is also known as inference का मतलब तो आप समझते हैं conclusion. तो statistical conclusion you will get, and hence it is known as ANOVA. तो ANOVA का एनालिसिस बहुत अच्छा. ये एक पेपर, एक दो पेपर तो आप अपने जो भी आप रिसर्च कर रहे हैं, आप ANOVा पर भी बहुत अच्छा कर सकते हैं. अभी SPSS में 28 वर्जन में ANOVा के बहुत अच्छे फीचर्स दिए हैं. Maybe tomorrow I will tell you if someone remind me, right? Because time is quite less. I've many things to share with you, but I'm trying to give you because of my art कि आपको समझ में आए इसका पर्पस क्या है. Otherwise क्या होता है, जो मुझे पता है I will speak out, I will discuss, then I will go. No, it is not this. The deep rooted is concept क्या है. Whether you are within the concept or not, if you are in the concept, it means you are doing a wonderful research. It's because your mind activates, right? So I hope you have understood with these 2-3 examples which I gave you. ये थोड़ा सा उससे like it's somewhat higher degree from my previous example. So because here the concept is coming inferential statistics. उसमें कई सारे points add on होते हैं which I will tell you. Any questions, guys, so far? I hope the examples are clear to you. तो हम कुछ एक ग्राफिकल मदद से भी देख लेते हैं. So analysis of variance. वेरिएंस क्या होता है? वेरिएंस में काम करना जरूरी है या नहीं है, कोई बताए क्लास में? लेट मी ऑफ द स्क्रीन. यस गाइस, व्हाई द वेरिएंस एंड वेरिएबिलिटी इज इंपॉर्टेंट इन माय लाइफ और इन आवर लाइफ? Yes guys, quickly I'm waiting. You can respond in the chat window. वेरिएबिलिटी आप समझते हैं? ये वर्ड आपने कभी सुना है? हैव यू हर्ड दिस टर्म बिफोर? वेरिएबिलिटी. व्हाट डू यू मीन बाय वेरिएबिलिटी? लेट मी आस्क यू. लेट मी टाइप. मीन बाय वेरिएबिलिटी. What do you mean by variability and how it is important in our life? Because we all are researchers, we know that, but how it is important. I always, love to work in variability. What is variability? Yes, guys, please be with me. Are you with me? Yes or no? Type yes. Including me, we are total 19 people over the call. Yes, Mr. Farhan, Parveen, Amitabh ji, Dr. Kunal, you have something to share? Your views?
Sir,
Yes, please.
variability is the different types of options we have. for training.
Different type of option. So what is the need? Why people should go and people prefer to go for variability? Because there are certain set of people, those who don't like variability. They want to be just in the same format, isn't it?
Sir, for exploration of new techniques.
Yeah, for exploration of the new ideas, new happenings going around the world. So if in life our life or persona is like that, we should go, otherwise, my life is getting bored or we are feeling bored. So variability is a principle of our life also. If you talk to the medical doctors also, they always suggest you, okay, do something, because these days people are stressful, right? So what they do, they say, okay, you change your setting, you go to some mountainous region, spend some time, you use less technology but interact with humans directly, like that. So what is this? This is variability. So why I've asked this question, if you see here, because of this. So analysis of variance is a ratio. Okay, variability ratio है, analysis of variance. So variance between plus variance within is equal to total variance. ये formula है, ये आप note कर सकते हैं, those who want to do or take the picture. So F is equal to between or within. तो between ऊपर आता है numerator, within in the denominator. So F is equal to, so generally we calculate the F ratio. इसको हम लोग F ratio भी बोलते हैं. Where you can see it is the normal distribution curve. This is a normal distribution curve. So this side, if you see the LHS, left side and right side. Right side is this one. So you can see. So between and within. तो इस तरफ क्या है? Among and around. F is equal to among oblique around. Around means within. So F ratio. Both are equal. So variance between, variance within. Within means the inside. The between means that particular area, region. Here you can see this is the region. This is the perfect curve you can say. We can call it as a bell curve also. तो bell curve अगर आप देखेंगे यहाँ पर पूरा यूज हो रहा है. अगर आप इसको intercept करेंगे, you will see the same. It means we are covering and choosing the complete interval of that particular area. It means everything is perfect. Bell curve को perfect curve क्यों बोलते हैं? Why we call it this bell curve is a perfect curve? Because if you take the mean of this, it is perfect. LHS is equal to left hand side is equal to right hand side. It's like that. But variability is important. तो variability ratio क्या है? ANOVA. ANOVA का variance कैसे calculate करते हैं? Variance between plus ये mathematical है. I'm just taking you to the direction of the mathematics, right? That is what. यहाँ पर हम कुछ देखेंगे कुछ picture. ये एक मीन है. ये मान लीजिए ये एक कर्व है किसी ग्रुप 1 का. ये ग्रुप 2 का है. मीन 1, मीन 2. तो देखेंगे, राइट? और इसका ग्रैंड मीन क्या है? इन बिटवीन. सो टोटल वेरिएंस पूरा देखिए. अगर इसका एनालिसिस करेंगे, इफ यू सी द रेड कर्व हियर एंड सी द माउस, so among group variance, within group variance. So one side is of the among group variance, another side is the within the group variance. ये mean 3 है. So mean 1, mean 2 and mean 3. But the total variance is the complete total variance. क्या बोलेंगे? Among group variance plus, अगर आप previous देखेंगे, वेरिएंस बिटवीन प्लस वेरिएंस विदिन इज इक्वल टू टोटल. टोटल वेरिएंस कब मिलेगा? जब मेरे को बिटवीन और विदिन का वेरिएंस पता होगा. नहीं तो जनरली मैंने काफी लोगों को देखा, आपने भी देखा होगा स्टडीज में, टोटल वेरिएंस पीपल अंडरस्टैंड एक सिचुएशन ले लेते हैं वेरिएंस बिटवीन. या समटाइम्स दे सिलेक्ट द वेरिएंस बिटवीन. यस
Sir, I wanted to know what is the meaning of within and between here.
या आई एम कमिंग टू दैट. दिस इज या ये देखिए यहां पर आप देखेंगे ये इट इज अ कंप्लीट वन. इट इज अ कंप्लीट वन. दिस ग्रीन कर्व, डिड यू सी दैट?
Yes, sir.
तो एक सिचुएशन ये ले लेते हैं, पहले नीचे वाला ले लेते हैं. द बिलो वन वी कैन सी इन दिस हियर इज दिस इंटरवल. You can see curve to curve, though this curve is never touching, right? But the representation, we believe that it is a perfect curve and there is no outlier, right? There is no outlier. So this situation, then this situation arises, then this situation. So if you see F is between and within, I'm coming to this, it will be clear from the next picture also. तो ये जो complete है, ये complete जो direction है, अगर आप देखेंगे, ये among group variance है, ये within group variance है. बिकॉज टोटल वेरिएंस क्या होगा? एक कर्व का एक सिचुएशन में आपने देखा होगा वेरिएंस बहुत अच्छा है, यू जस्ट रिमेंबर, बट कितना अच्छा है पीपल ना नेक्स्ट क्वेश्चन अराइज रिसर्च. देन वी से दैट ओके, तो हम डिस्ट्रीब्यूशन देखेंगे. अभी तो यहाँ आप देखेंगे इट इज ए कंप्लीट परफेक्ट कर्व, तो जितना ये बराबर है उतना ये बराबर है, बट समटाइम इट इज ए स्क्यूड वन, ये कुछ टिल्ट है अगर आप देखेंगे. तो देन द अमंग द ग्रुप वेरिएंस विल बी हाई, देन द विद इन द ग्रुप वेरिएंस विल बी लो, बट उनका टोटल सम होगा दैट वी कंसिडर फॉर द टोटल ग्रांट में. ठीक, इसको और समझ लेते हैं दूसरी पिक्चर से. ये देखिए ग्रुप ए, ग्रुप बी, two situations are in front of you. So here you can see one situation, another situation, the other third situation. The blue curve, yellow curve and green curve, right? So variance between groups हम कहाँ से लेंगे? The curve which is meeting, तीनों का जो कर्व मीट कर रहा है, which is the mean. आप देखेंगे यहाँ पर एक मीन है, another mean, another mean. तो वेरिएंस बिटवीन ग्रुप्स, ये ग्रुप्स है, तो इनके बीच का जो वेरिएंस है दैट इज बिटवीन, राइट? वेरिएंस विद इन ग्रुप साइड में होगा द एंटायर वन. तो ये बी सिचुएशन में देखते हैं वेरिएंस बिटवीन ग्रुप्स. तो देखिए ये अलग अलग ग्रुप्स है, पहले ये एक साथ थे, अभी ये अपार्ट है, राइट? सो वेरिएंस विद इन द ग्रुप इज द टोटल इंटरवल ऑफ द वन ग्रुप, another group 1, another group. So within variance within the group is this, but variance between the groups, between मतलब उन सबके ग्रुप के बीच का क्या है? So that is mean 1, M1, M2, M3, M4, like this. Okay, so that is variance between the groups and variance within the group. Group within means उस group के अंदर, inside. That is that complete one group. वो separated है, ये combined. So that is the difference of this situation. F is equal to between the groups and the within the groups. I hope it is. और इसको दूसरे word में भी क्या बोलते हैं? F is equal to among the group or around the group. दोनों ही same है. Is that okay with you guys?
Yes, sir.
Yeah, thank you. अब आपको थोड़ा और क्लियर होगा वेरिएशन बिटवीन द ग्रुप्स. वेरिएशन कैसे होता है? वेरिएशन मीन्स द चेंज इन द मीन. तो आप देखेंगे दोनों कर्व्स में डिफरेंसेस अमंग ग्रुप मीन्स, तो इनके ग्रुप मीन चेंज हो रहे हैं. अगर आप देखेंगे इसका ग्रुप मीन इस मीन से है ना, और इस ग्रुप का इस मीन से है. तो ये हो गए अमंग ग्रुप मीन्स. एक तो ये सिचुएशन हो गई, एक ये सिचुएशन हो गई, एक पूरा सिचुएशन हो गया. इज दैट ओके? बिटवीन ग्रुप वेरिएशन. अब विद इन ग्रुप वेरिएशन वो ग्रुप अलग ही है, बट उनका आपस में विद इन द ग्रुप वेरिएशन क्या है, कोई कम हो रहा है, कोई ज्यादा हो रहा है. इट इज लाइक अप एंड चेंजिंग. सो वेरिएबिलिटी विद इन ईच ग्रुप इसको बोलेंगे, विच इज द राइट फिगर, एंड द लेफ्ट फिगर इज द डिफरेंसेस. इसको बोलेंगे वेरिएबिलिटी, नहीं बोलेंगे डिफरेंसेस. प्लीज नोट डाउन. यहाँ पर बहुत सारे लोग गलती करते हैं. डिफरेंसेस अमंग ग्रुप मीन्स, क्योंकि ग्रुप मीन्स चेंज हो रहा है, डिफरेंस अंतर. वेरिएबिलिटी क्या है? वेरिएबिलिटी विद इन ईच ग्रुप मीन्स चेंज इन द ग्रुप, वेरिएशन इन द ग्रुप. दैट इज. तो कहीं आपने देखा होगा डिफरेंसेस पीपल से, एंड समटाइम पीपल से वेरिएबिलिटी, बट ओवरऑल कॉन्सेप्ट इज ऑल अबाउट द वेरिएंस. राइट? आई होप यू हैव अंडरस्टूड. आप इसको समझ लीजिए, इसको मान लीजिए ऐसा होता है. बिटवीन द ग्रुप वेरिएशन, डिफरेंसेस अमंग द ग्रुप मीन्स, विद इन द ग्रुप वेरिएशन, वेरिएबिलिटी विद इन द ईच ग्रुप. You can take the picture also. I like this slide, so that's why I brought, so that you can better understand about this. Values वही है, ग्राफ वही है, उनकी अरेंजमेंट्स वही है, बट ग्रुप के मीन का देखने का तरीका अलग अलग है. That's why. I hope it is clear to you guys. Shall I move?
Sir.
Yeah, thank you. अब मैं आपको एक नया कॉन्सेप्ट बता रहा हूं. These are the three terms: ANOVA, ANCOVA, and MANOVA. Generally, people are confused also in this, so I just thought to bring some information, difference between ANCOVA, ANOVA, and MANOVA. So ANOVA तो हमने समझ लिया, analysis of variance. Short form is ANOVA. The full form is analysis of variance. AN stands for analysis का AN, OF का O, और variance का VA. First letters, 2 letters is VA. That is ANOVA. The researcher asked whether the mean of the single quantitative dependent variable Y differs significantly across the groups or level of the factors. It depends. So that is ANOVA. What is ANCOVA? ANCOVA is analysis of covariance. इसमें co add हो गया, CO in front of the variance. That is ANCOVA. ठीक है? So the researcher asked whether the mean of a single quantitative dependent variable Y differs from the significant across the groups or level of the factors. को कुछ लोग level of factors भी बोलते हैं. That's why I'm using it. कुछ लोग factors level बोलते हैं. उसका दोनों का मतलब वही है, right? So when the group means have been adjusted for some covariate. Covariate means another variable which is reflecting in your analysis. So when the group means have been adjusted for covariate, that which is denoted by X. A covariate is the participant characteristic. कोई विशेषता है किसी participant के, that is assessed prior to the treatment, that may be confounded with the type of treatment or and predictive of the Y outcome, right? So adjusted group means may be significantly different even when unadjusted group means do not differ. तो एक किसी variable का add on होना, that is known as covariate. तो उस केस में मान लीजिए आपकी जो फर्स्ट सिचुएशन थी जो अब तक हमने डिस्कस की, वॉट एवर वी हैव डिस्कस सो फार, ए न्यू ग्रुप मीन हैज बीन एडेड विद सम कोवेरिएट एक्स. तो अंडर दो सर्कमस्टांसेस वी विल यूज एनालिसिस ऑफ कोवेरिएट. उस समय हम एनालिसिस ऑफ कोवा अनोवा यूज नहीं करेंगे, अनकोवा यूज करेंगे, राइट? सो ये एक टेक्निक है, आप नोट कर लीजिए कि जब कोई कोवेरिएट एक्स उसमें एड ऑन होता है, उसकी कोई पार्टिसिपेंट कैरेक्टरिस्टिक्स एड ऑन होती है उस प्रोसेस में, प्रायर टू द ट्रीटमेंट, आउटकम से पहले कि अभी कोई फाइनल डिसीजन नहीं हुआ है, तो उस कंडीशन पे हम लोग एनालिसिस ऑफ कोवेरियंस यूज करते हैं। मनोवा क्या है? मल्टीवेरिएट एनालिसिस ऑफ वेरिएंस। देखिए, मल्टीवेरिएट एनालिसिस मैंने कुछ बात शुरू की थी इन द बिगनिंग। आई हैव स्टार्टेड सम डिस्कशन ऑन मल्टीवेरिएट, एंड these days all people blindly they are using multivariate analysis without having knowing the facts and all, because it's a rat race, you know, in researchers fraternity. Rat race is there, a lot of pressure is there from our institution to publish more and more. So some people are by default they are using it, some people are using sensibly. So I'm not coming into the any controversy, but both the situations are correct, right? So Manova, the researcher asks whether the list or set of vectors, because vector will give you the direction of that particular mean. So you can say the list, some people say set, some people say vector of means on multiple dependent variable. बहुत सारे dependent variables हैं, जैसे मान लीजिए आपकी सैलरी बहुत सारी चीज़ों पर निर्भर करती है, आपका सोचने का तरीका, आपका काम करने का तरीका, आपकी इंस्टीट्यूशन की फंडिंग, आपके टाइप ऑफ स्टूडेंट, कितने सारे फैक्टर्स हैं, है ना? तो अगर आप ये एग्जांपल समझेंगे तो योर पर्सनैलिटी, sorry, your future, or you can say your personality as a faculty or as a researcher in your university or around the university depends upon various multiple dependent factors, variables, right? So that is y1, y2, y के differ across group, और ये सारे group में across में different भी है, because आप age अलग है, आपका सोचने का तरीका अलग है, because if you see biologically we all are human being and we are unique people, isn't it? हम लोग सब लोग unique है. Your capability is much more higher than anyone in this forum, right? So it depends upon. But कुछ ऐसी study आप कर रहे हैं, researcher ask whether the list of set of vectors of means of multiple dependent variables. तो उस condition में आप multivariate analysis of variance use करेंगे. So in this case, the analysis takes into account the pattern of intercorrelation. तो उसमें हमको क्या निकालेंगे? Intercorrelation, आपस में संबंध निकालेंगे. जैसे मेरा आपके साथ कैसा व्यवहार है, आपका किसी और दूसरे के साथ कैसा है, आपके स्टूडेंट के साथ कैसा है, या मेरे जैसे लोग के साथ कैसा, लाइक दिस इंटरकोरिलेशंस, आपस में इंटरकोरिलेशन अमंग द वाई आउटकम वेरिएबल, उन आउटकम वेरिएबल के साथ, बिकॉज बहुत सारे वेरिएबल्स आ गए. एंड वेरिएट मीन्स मल्टीवेरिएट, मल्टी मीन्स बहु, मैनी वेरिएबल्स एनालिसिस ऑफ द वेरिएबल. तो उसमें हम लोग यूज करेंगे मनोवा. ANCOVA करेंगे, only one variable as a co-variable is added into your problem. और ANOVA के केस में क्या था? It was only one case depending on the across the group. So that was ANOVA. So I hope that things are clear to you and you can take the judgment. ये बड़ा confusing होता है, काफी लोग मेरे पास आते हैं, सर ये समझ में नहीं आ रहा. So with this easy example, I think you can differentiate easily what is ANCOVA, when to use, what is ANCOVA, when to use, how to use, and ANCOVA, how people are using in their research. बाकी ये कुछ mathematical, I will share this handouts with you. कुछ conditions हैं. It is not like that, because these things are framed by researchers, थ्रू आउट द इंटरवल. जब से रिसर्च हो रही है, काफी चीजें चेंज हो रही हैं, एंड दीज सॉफ्टवेयर्स आर इंटीग्रेटेड बेस्ड ऑन दीज रूल्स एंड रेगुलेशंस. लाइक एक जनरल लीनियर मॉडल GLM बोलते हैं, GLM इज देयर. सो यू कैन सी डिफरेंट वेरिएबल्स आर देयर, कैसे करते हैं. बट आपके लिए अगर आप बहुत ज्यादा इंटरेस्टेड है तब तो ये याद रखने की जरूरत है. But suppose you are not interested to remember all this, even I'm also not saying that you remember, you should know the basic concept, what is going behind the screen. Algorithm कैसे काम कर रहा है, which kind of correlation you are using. वैसे like Pearson correlation आप use कर रहे हैं, या Carl Pearson को use कर रहे हैं, Spearman correlation use कर रहे हैं, कौन सा use कर रहे हैं वो आपको थोड़ा idea होना चाहिए. That I always say in my RM class also, because we are not made for this research. Research is just to use these things for my own purpose of the question, and I will get the correct response. So I look at the research that way. Though I can provide the full discussion on full day on this, what is p-value and what is the connection. बहुत advanced में भी काफी काम कर रहे हैं, अभी मैं कर रहा हूँ, आप लोग भी कर रहे होंगे. Like simple linear regression कैसे करते हैं, multiple linear regression कैसे करते हैं. These softwares are there, like PLSS Smart is there. पहले हम लोग अनोस में करते थे, मॉडल बनाते हैं. Modeling is also quite, so these are very much basic, but I would urge you that you should know and some familiarization, and you can distinguish. अगर आप distinguish करना समझ गए, आप में फर्क करना समझ गया, it means you are doing the wonderful research for you. for yourself. So guys, these are the 4 assumptions taking the journey of the ANOVA. So these are the 4 assumptions हम लोग लेते हैं. Generally these several assumptions need to be fulfilled. ये conditions होती हैं क्योंकि कुछ वैज्ञानिकों ने देखा है, साइंटिस्ट लोगों ने देखा है, because data is not interval data, right? कुछ अलग तरीके का डाटा. आजकल तो आपने देखा होगा काफी लोग रिसर्च कर रहे हैं, जैसे मैंने बताया सोशल मीडिया एनालिटिक्स, ट्विटर एनालिटिक्स, तो data is coming in different formats. So sometimes the data is interchanged or by chance it is interchanged. You never know what kind of data is coming. So it's a headache to the researchers to how to filter out and all. So all these things, these are the challenges. I think we all are facing these challenges. So interval data for the dependent variable is must. Okay. Assumption आपका क्या करना है? ये 4 conditions है. Assumption है interval data of the independent variable is must. Normality should be applied. Homoscedasticity is also there, and no multicollinearity. मल्टीकोलिनिटी नहीं होनी चाहिए, डेटा इन्फ्रिंज नहीं होना चाहिए, डेटा मल्टीपल नहीं होना चाहिए. होमोस्केडेसिटी इज कॉन्सेप्ट आल्सो बिकॉज आउटलायर कुछ आ जाते हैं डेटा में, डेटा नॉर्मल नहीं रहता, ऑल दिस थिंग. आई थिंक आपके गाइड्स ने, आपके कोलीग्स ने भी आपको बोला होगा डेटा इज नॉट नॉर्मल, सो अगेन यू आर कलेक्टिंग द डेटा लाइक दिस. सो आई एम जस्ट गिविंग यू these insights so that you can better correlate what concept I am discussing with you guys. I hope you are with me. If you are there, please type in the chat window. Okay. Now what are the 3 types of ANOVA? ये 3 तरीके का ANOVA है, इसके 3 प्रकार हैं. There are 3 types of ANOVA as there, type 1, type 2 and type 3, sum of squares. So they do not give the same result. ये तीनों रिजल्ट अगर आप देखना चाहेंगे सॉफ्टवेयर से, these are not the same, whether they are different. So type 1, type 2, type 3 ANOVA because algorithms are defined that way. तो ये 3 टाइप मैं आपको बता रहा हूँ according to the decision tree chart. कैसे हम सिलेक्ट करते हैं या कैसे क्यों सिलेक्ट करना चाहिए. तो थोड़ा आगे चलते हैं. Now it's a journey ahead from the concept what we discussed so far. So ANOVA decision tree for the choice of ANOVA type. So the situation is, do you have a serious theoretical consideration to inflate the importance of one of your variable? क्या आपके पास बहुत ज़्यादा theoretical basis है उस variable को deal करने के लिए? Like example, proof the impact of a specific variable. कोई proof है, अगर आपके पास proof है तो उसमें से 2 बातें होती है. That is, one is type 1. और अगर दूसरी situation है, is there any interaction be expected between the independent variable, तो उसमें फिर एक और 2 बातें थे, टाइप 3 एंड टाइप 2. तो अगर आपका इंटरेक्शन की बात है, टू बी एक्सपेक्टेड बिटवीन द इंडिपेंडेंट वेरिएबल, तो इंडिपेंडेंट वेरिएबल के लिए टाइप 3 एंड टाइप 2 आर अप्लाइड. और अगर आपका डायरेक्ट थ्योरेटिकल कंसिडरेशन है, वेयर यू आर कंसर्न विद योर डिपेंडेंट वेरिएबल, तो डिपेंडेंट वेरिएबल के केस में, जिसमें जैसे मैंने पहले बताया एक ही वेरिएबल को आप लेके चलते हैं, इंपॉर्टेंस ऑफ वन ऑफ योर वेरिएबल्स, देन यू सिलेक्ट द टाइप 1. तो ये कंडीशंस है गाइस. ऐसा नहीं है आप रेंडमली टाइप 2, टाइप 3 आप सिलेक्ट कर लेंगे. जनरली लोग कर रहे हैं, बट थोड़ा सा आपको आइडिया होना चाहिए. टाइप 1 में मैं डिपेंडेंट लेके चल रहा हूँ, और इंडिपेंडेंट के केस में जहां पर मेरी एक्सपेक्टेशन इंटरेक्शन है उन वेरिएबल के साथ, उसमें टाइप 2 एंड टाइप 3 हम लेके चलते हैं, बिकॉज उनकी सिमिलरिटीज है. सो इट इज अगेन अ वेरिएशन. टाइप 1 कब सिलेक्ट करना है, टाइप 2 कब सिलेक्ट करना है, टाइप 3 कब सिलेक्ट करना है, बट दीज आर द 3 टाइप्स ऑफ ANOVA इज ऑल्सो अवेलेबल. और तीनों के रिजल्ट अलग अलग है. थोड़ा सा सिमिलरिटी आता है. सपोज 4.21, सपोज one is giving 4.21 or maybe let's say 4.1, but दूसरे के केस में आ गया 3.923. तो 3.9 is nearest to 4 and the 4 is nearest to the other in type 1, 4.1. ठीक है, but for the researcher it's a not a it's a huge difference for researchers. But as a layman, 3.9 is nearest to 4 and 4 is nearest to 4.1. So but researcher are always particular, should be particular with these values differences, right? How many types of ANOVAs are there? तो ये कुछ एक चार्ट में आपके सामने लेके आया हूँ. These are the definition, 1-way, 2-way table, and कैसे यूज करना है, डिग्री ऑफ फ्रीडम क्या होगा, सोर्स ऑफ वेरिएशन क्या है, कॉलम्स के बीच की बात कर रहे हैं, रोज के बीच की बात कर रहे हैं, एरर्स के देख रहे हैं या टोटल देख रहे हैं, तो उसमें हम लोगों की ये कंडीशंस होती है. बट दीज डेज नोबडी इज कैलकुलेटिंग. इफ यू कैलकुलेट मैनुअली, व्हाट विल हैपन? Definitely you will get some error. और कैलकुलेशंस आर वेरी मच लेंथी गाइस. तो इसीलिए हम लोग एडवाइस करते हैं आप कंप्यूटर का इस्तेमाल करें, यू यूज द कंप्यूटर वाइजली. पहले तो आपको डेटा, मैं आपके कुछ थंब रूल बता देता हूँ. आपका डेटा क्रिस्प होना चाहिए, within the limits होना चाहिए as per the condition, like normality should be there, homoscedasticity is not there, multicolority is not like this, in this way, right? Once the data is shown, then you can run your analysis. Otherwise, what will happen if you randomly import the data to your system and then you are, doing some analysis, maybe you may be on the different track. Generally, it happens. But if you're sure, it's okay. If you are expertise in that area, it's okay. But if you are beginner or no idea, because I have seen in various workshops, people are facing problem in exporting and importing the data in the software. So they create some mistake. Even there, one problem I will tell you, even they are not capable enough to define the type of data. Normal data है, कौन सा variable normal है, कौन सा ratio है, so they are facing those kind of problem. और वहां पर अगर वो change आया, then definitely it is reflecting in your result. अगर वहां आपने चेंज नहीं किया SPSS में या कोई भी आप सॉफ्टवेयर यूज कर रहे हैं, तो आपका जो पूरा मेहनत है, वट एवर द एफर्ट्स यू पुट इन, दैट विल बी इन द अपोजिट डायरेक्शन. और वेरिएशन बहुत आएगा, बट ये पकड़ में नहीं आएगा. इसलिए मैं आपको क्वेश्चन बता रहा हूँ कि आपने नॉर्मल टाइप का डेटा आपने सिलेक्ट नहीं किया, विच टाइप ऑफ डेटा, विच काइंड ऑफ वेरिएबल यू आर डीलिंग विद, उसका स्केल क्या है. स्केल अगर आपने सही नहीं लगाया, द एंटायर स्टोरी, क्योंकि ये सब बातें जो आप और हम डिस्कस कर रहे हैं, दिस विल कम लेटर ऑन. But suppose your data is not defined, the scale is not defined, ratio scale है, interval scale है, normal scale है, कौन सा scale है, वो देखना बहुत जरूरी है. So please mind it, it's a caution. So that's why I'm highlighting this issue before going to the these analysis examples and application. So mathematically we have read all these things in books, but अभी आजकल याद करने का जरूरत है. That I can boldly say, because now you apply this energy to just take the result and interpret. Interpretation पे ज़्यादा काम कीजिए. That is my suggestion if you want to publish, because that is the purpose of these short-term program, FDPs, webinars. मैंने बहुत सारे webinar FDPs लिए, different topics पर लिए, तो काफी लोगों को मैंने बताया कि interpretation पे काम ज़्यादा कीजिए. Interpretation is unique, which is coming from your effort, from your mind directly, which is not exist on Google, not any platform at all. If it maybe exists by chance, maybe your analogy is different, maybe your variables are different, your characters are different, your representation style is different like this. So that is a part. So these are the two types of ANOVA that are commonly used, one-way ANOVA and the two-way ANOVA. ज़्यादातर लोग दो style को use करते हैं. Third-way ANOVA, if it is the chance is there where you are talking about the expected value of the independent variable, then you can go with this. Otherwise, you are left with these two, one-way ANOVA two. It will explore these important statistical tests and difference between these two type of ANOVA tests. So what is one-way ANOVA? ये थोड़ा सा मैंने बताया है, इसकी हिस्ट्री आप थोड़ा सा पढ़ लीजिए. One-way analysis of variance is used for, ये अब खत्म करते हैं, then we will move to the factor analysis, okay, which is the other part. So I'm sure the things are, concepts are clear to you as far as the ANOVA is concerned. आप ये एग्जाम्पल यहाँ देख सकते हैं. You could use a one-way ANOVA to understand whether exam performance differs based on the text anxiety levels amongst the student, dividing students into three independent groups, maybe low, medium, large, maybe high stress students. So you can use one-way ANOVA. Why is ANOVA analysis of variance? So based on the, I think we have already discussed, appropriate because of inferences about the means are made by analyzing variance. ये उसके कुछ फैक्टर्स मैंने बताया, वन-वे ANOVA, N-way ANOVA, N-way ANOVA भी, because here number of variables are added. ANCOVA मैंने आपको बता ही दिया, it is greater than one independent factor, but consists both categorical and continuous. So these are some in addition to the previous discussion what we had. Factor analysis, very important, yes. So factor analysis, it isn't quite popular term in the or among the across the researchers. It is a powerful data reduction technique that enables researchers to investigate concepts that cannot be easily measured directly. तो जिन factors को हम directly measure नहीं कर सकते या हमें लगता है उसमें factors बहुत ज़्यादा हैं, तो उस condition में हम लोग factor analysis recommend करते हैं. Data reduction technique इसलिए बोलते हैं कि हम data को reduce करते हैं. Like one variable is not perfect, then go for the other variable. Like so, by boiling down a large number of variable, आपने देखा होगा बहुत सारे problem है. Thesis जब आप करते हैं या आजकल तो ज्यादातर प्रॉब्लम मैनेजमेंट की, सोशल साइंस की, विच यू आर डीलिंग विद वेरियस variables. So by boiling down a large number of variables into a handful of comprehensive underlying factors, comprehensive will be underlying factors. Please remember this keyword, these underlying factors, right? So underlying factor means all भी factors है जो हमें मालूम नहीं है, या हम जब literature review करते हैं then we came to know. So under those circumstances, we recommend researchers to go for the factor analysis. It is an approach basically. It is an idea to reduce the data in such a way that which you can't measure directly. इसका मतलब ये है कि आप superficially research नहीं कर सकते या upper side से नहीं कर सकते. You have to be go deeper and deeper, discuss, create some factor, constructs निकालिए, factors निकालिए, then you analyze. So I hope it is clear, the message is clear to everyone. So factor analysis is a way, एक रास्ता है to take the mass of data. Mass of data means the pool, the big pool of the data, and shrinking into smaller data set. छोटे छोटे data set में उसको बांट दीजिए. There is a more manageable and more understandable. It is a way to find hidden pattern. आपने देखा होगा एक और approach होती है decentralized approach. आपने देखा होगा in your day-to-day life, you know, whenever the things are not ready, the people follow the decentralized approach. So what happened with these banks? Banks are merged because some banks were profitable, some banks were they were not profitable, lot of debt was there. तो गवर्नमेंट ने क्या किया, उनको डिसेंट्रलाइज अप्रोच से उनको डिवाइड कर दिया, उनको मर्ज कर दिया. पहले डिवाइड एंड रूल, देन मर्ज विद द अदर बैंक विच वर प्रॉफिटेबल. सो इट इज ऑल्सो मैनेजेबल श्रिंकिंग. तो अभी आप देखेंगे नंबर ऑफ पब्लिक बैंक्स आर क्वाइट लेस. पहले ज्यादा थे, अभी गवर्नमेंट हैज गिवन. सो इट इज व्हाट, सो यू कैन रिमेंबर दिस एग्जांपल. जब कहीं बात नहीं बनती, यू ऐड सम वेरिएबल टू द अदर वेरिएबल्स. दैट इज आल्सो अनदर वे टू श्रिंक योर डेटा in smaller groups which are manageable, which you can understand. So same fundamental thing you can apply in your research variable also, which is known as factor analysis. You can see this chart. It's a very interesting chart. You can say, here one variable is giving you, suppose value. Why I've chosen this area, मैं थोड़ा आपको बता देता हूँ. 0.787. एक फैक्टर की वैल्यू आ रही है 0.87, दूसरे फैक्टर की आ रही है 0.785. The other factor which I am getting is question number maybe 53. I am getting 0.727. तो अगर आप देखेंगे, these variables are quite nearest, but their factor loadings are quite different. 0.787 में 0.85 में 0.002 का डिफरेंस है. 0.727 में 6.06 का डिफरेंस है. Like this. So it is nearby. So factor will give you the idea about a particular question which is dealing with the variable. आपने देखा होगा कुछ questions हम लोग बना लेते हैं. Which question is relevant, not question. So it means what is happening? We are going into deeper and deeper section of our research. उस research में हम deep में जा रहे हैं, उनको analyze कर रहे हैं, उनको देख रहे हैं, for which it is relevant. So what is the basic purpose of while concluding this? So factor analysis is used to uncover the latent structure. Uncover means जो उसके अंदर hidden constructs हैं, जो अभी तक हमने नहीं जाने थे, उनके बारे में हम जानते हैं कि वो कितने properly aligned है, उनका क्या मतलब है मेरे research में, and that's why we create different models. तो आपने देखा होगा एक popular analysis which is known as structure equation modeling. आपने नाम सुना होगा, have you heard? Structure equation modeling is also an integrated approach where we do factor analysis and canonical analysis. So बहुत सारे analysis like we do this. So it reduces attribute space from a large number of variables. तो हम लोग क्या कर रहे हैं, बहुत सारे variable को छोटा छोटा करके छोटे छोटे models में convert कर रहे हैं. उसको हम different weights देते हैं, weights को analyze करते हैं, उससे हमारे उस variable का हमें वेरिएंस पता लगता है और उसके हिसाब से हम उसका डिसीजन लेते हैं whether this particular variable is influencing in my research and how much. फिर हम उसको इंटरप्रेट कर. सो दैट इज द एनालॉजी ऑफ डूइंग द फैक्टर एनालिसिस. ये जितना मैं आसानी से भी बता रहा हूँ, इट इज नॉट दिस एक्चुअली मैथमेटिकली इट्स क्वाइट कॉम्प्लेक्स because sometimes your variables are quite giving the same loading, same variables values than what will. So इसके कुछ नियम कानून है. There are some steps of rules. CFA कब करना है, कंफर्मेटरी फैक्टर एनालिसिस. EFA कब करना है. EFA अगर आप करेंगे तो EFA में कुछ एनालॉजी बहुत ज्यादा है. So I'm not going into detail because it's a basic update, but I will try to give you some glimpse of this, right? So it provides a tool for analyzing the structure of interrelationship. Interrelationship का statistical name क्या है? That is correlation. कि उनका आपस में संबंध कैसा है, like that is correlations among variables by defining a set of variable which are highly correlated known as factor. जो ज्यादा से ज्यादा related है उसको हम factors बोलते हैं, जो कम related है उसकी हमें जरूरत नहीं है, because that may be not a good choice for my model, for my research model, right? So factors are assumed to represent dimensions within the data. That is also there. ये बड़ा important aspect है, आप note करना चाहे note कर लीजिए. Factor are assumed to represent dimensions within the data. तो फैक्टर को हम लोग मान के चलते हैं कि उसकी कोई डिमेंशन है और उसका डेटा में कुछ वजूद है, उसका महत्व है. So that's why that is the purpose of doing the factor analysis. In the which situation it is useful? इसकी situations भी होती है, जैसे अभी मैंने बताया. In social economic status, you know, various variables are there. Dietary patterns में बहुत सारे variables हैं. Psychological skills में बहुत सारे variables हैं. तो उनको हम कैसे पता लगाएंगे? So factor analysis is one of the statistical measure technique. तो हम उससे इन्वेस्टिगेट कर सकते हैं. तो जहाँ कॉम्प्लेक्स प्रॉब्लम है, जहाँ सोशल प्रॉब्लम है, और आजकल अगर आप देखेंगे, आजकल जो लोग भी रिसर्च कर रहे हैं, ऑल आर सोशल इकोनॉमिक स्टेटस प्रॉब्लम, और यू कैन से ऑल आर सोशल साइंस प्रॉब्लम. Whether you are dealing with HR, psychology, maybe आजकल काफी सारे लोग, you know, people are working from the computer science like machine learning, you know, data analytics, cloud computing, artificial intelligence, AI, MI, machine learning, ML, so all these things. Even I teach these courses like data analytics and all. So बहुत सारी जो problems हैं आजकल, so that's why it is recommended. तो आजकल एक प्रचलन में है, it's in the hype of the researcher. कि that factor analysis अगर आपने नहीं किया, it means you have not touched the in-grounded condition of the variables. Even we generally ask this question to the scholars, you know, in their, you know, progress committee meeting or like this. तो अभी क्या ये एक नियम बन गया है, it is a rule actually, कि अगर आपने factor analysis किया, only ANOVA किया है, तो it means you are not touching the model, you are not exploring hidden construct, जैसे भी हमने बात की, hidden latent variables like this. Okay, so that's why, so it allowed researchers to investigate concept that cannot measure directly, जिसको हम directly measure नहीं कर सकते हैं, indirectly हम measure कर सकते हैं. तो factor analysis is highly recommended under those situations for the research. What is factor analysis? Discuss in step by step. तो हम कैसे करते हैं वो थोड़ा सा आपके 5 स्टेप है. प्लीज रिमेंबर, सिलेक्ट एंड मेजर ए सेट ऑफ वेरिएबल इन ए गिवन डोमेन. उसके सिलेक्ट कर लीजिए, उसके वेरिएबल्स को बना लीजिए, उसके मतलब जितने भी वेरिएबल है उसका पूरा मेजरमेंट कर लीजिए. स्टेप 2, डेटा स्क्रीनिंग इन ऑर्डर टू प्रिपेयर द कोरिलेशन मेथड. ऐसी स्क्रीनिंग कीजिए डेटा का सो दैट यू कैन बेटर कोरिलेट. सबसे पहला ही नियम होता है रिसर्च में, यू फाइंड एंड मेक द कोरिलेशन मैट्रिक्स where the diagonal elements are 1. आपने देखा होगा diagonal elements हमेशा 1 होते हैं if you are measuring the correlation, and it is very easy, it's a click of mouse you will get, right? Third step is factor extraction. अब factor को निकालना है, you have to remove the factor which are you know, going deeper. It means you are going deeper in the concept and extracting the factor. Okay, this factor, that's why, you know, we researchers are doing more literature review कि कहीं कोई ऐसा factor तो नहीं which is very strong but it is not yet in my study of the metrics. So factor extraction is a very important, और ये दिक्कत वाला काम है. This is most difficult part where a lot of literature is required. इसलिए हम लोग बोलते हैं कंस्ट्रक्ट की एक लिस्ट बना लीजिए, कौन से फैक्टर किसको इन्फ्लुएंस कर रहे हैं, क्यों कर रहे हैं, कितना कर रहे हैं, like all blah blah, you know. So factor extraction is very much important, but yes, if you are well versed और ये सब प्रैक्टिस से आ जाएगा, you can do it. Now step 4 is factor rotation. फिर अब फैक्टर को चेंज करके देखते हैं कि which variable is close to that particular you know, my expected value of to increase the interpretability. So इसको नाम दिया है step 4, factor rotation to increase the interpretability, कि कैसे काम कर रहे हैं. क्योंकि rotation कब करते हैं? Whenever we do the rotation, because we want to match the one factor correlation with the other factor correlation, the value or maybe the variance, right? Or once all these things are done, then you interpret this, which is a most significant task. यहाँ पर लोगों की दिक्कत होती है, interpret नहीं कर पाते, या interpret करते तो maybe 1 or 2 line, which is not required. आपको एक पूरा लेख चाहिए, लेख, you know, the 2-page, you know, analysis, solid interpretation. So these days I'm working on lot of interpretation because it is the weaker area of any researcher across any area. मैंने काफी सारे लोगों को देखा from science, engineering, technology, management, social science and engineering also, and I am blessed so far. I have conducted 400 plus workshops across both India and abroad. So I've understood the thing कि people are lacking behind in the interpretation, how to reduce, how to decrease, so lot many things are there. So that is really important. And that's why it is not very easy to publish in ABDC journal and Scopus Index journals like that, because editor always want the new thing, the new dimension, the new concept in that area. So interpretation factors, so 3-step, 4-step, and 5-step. These are very you can say what is the correct word is the sensitive and difficult for the researcher. संवेदनशील भी है और मुश्किल भी है. तो यहाँ आपको काम करना है. स्टेप 3, स्टेप 4, स्टेप 5, स्टेप 2 तक तो आप कर लेंगे. दैट इफ यू आर डूइंग इट्स ओके, आई अप्रिशिएट इट. ओके, सो कुछ आपके आइटम इस तरह से होते हैं, आप देखेंगे. तो ये आपको फील कराने के लिए दिस 2 टाइप्स ऑफ फैक्टर एनालिसिस. तो जनरली 2 तरीके एनालिसिस होती है, एक्सप्लोरेटरी एंड कंफर्मेटरी. सो हियर यू कैन सी सपोज एंजाइटी इज द वेरिएबल. सो एंजाइटी इज डिपेंडिंग अपॉन विच टाइप ऑफ आइटम, आइटम 1, आइटम 2, 3, 4, 5, सपोज मेनी. फिर आप इसको रिड्यूस करेंगे बेस्ड ऑन the techniques, right, which are there. So this is generally out. So that's why we propose. So types of factor analysis based on these factors different. So EFA करते हैं exploratory factor analysis, CFA is common factor analysis, right? Principal component analysis, the PCA, जहाँ पर हम रोटेशन की बात करते हैं. Principal component analysis is rotating matrix, that all this stuff is there. उसका एक अलग से नियम कानून है, उसकी एक अलग से methodology है. So all these which you are there and see here, 1, 2, 3, 4, these are independent, sessions are required for this. But अभी मैंने कुछ बताया because I think time is still with me, still 13 minutes to go. Let me see. So general linear model GLM is there, image factoring is there, maximum likelihood method. ये बड़ा पॉपुलर हो रहा है, आप नोट कर लीजिए. आजकल अगर आप पेपर पब्लिश करना चाहते हैं, सो एडिटर्स आर लुकिंग फॉर कि कितना लाइकलीहुड मेथड आपने यूज किया. तो दिस इज इन क्वाइट, यू कैन से, इन पॉपुलैरिटी. सो प्लीज मेक यूज. फैक्टर लोडिंग इज देयर, फैक्टर स्कोर इज देयर. फैक्टर स्कोर बहुत लोग कम बताते हैं, इसको आपको बताना बहुत जरूरी है. आइगन वैल्यूज का डिस्कशन कीजिए अपने पेपर में. सो आई एम जस्ट गिविंग यू सम टिप्स आल्सो, एज सम पार्टिसिपेंट सर वाज आस्किंग कि इट इज वेरी डिफिकल्ट फॉर सुपरवाइजर्स एंड स्टूडेंट, which I don't remember the name of the gentleman, but I understood. तो उनके टॉपिक का कनेक्शन यहाँ पर होगा. सर मेरे पेपर में फैक्टर स्कोर है, आइगन वैल्यूज में बता रहा हूँ, रोटेटिंग मेथड में बता रहा हूँ, और बाकी कॉमन जो सब लोग बता रहे हैं वो तो आप बता ही रहे हो. तो आपका जो फोकस होगा वो बहुत एनरिच हो जाएगा रिसर्च पेपर में. सो आई एम जस्ट गिविंग यू सम डिमेंशन. तो आप जैसे फैक्टर लोडिंग की बात कर रहे हैं, MLM की बात करें, मैक्सिमम लाइकलीहुड मेथड की बात करें, तो काफी सारे पेपर मैं भी रिव्यू करता हूँ, आप लोग भी करते होंगे. तो ये जो मेथड्स हैं इनकी कोई ज्यादा चर्चा नहीं कर रहा है. तो अगर आप करेंगे तो यू आर इंक्रीजिंग एंड यू आर ब्यूटिफाइंग योर रिसर्च पेपर ऑल्सो. कुछ नया चाहिए जो वो नया यहाँ से है. बाकी PCA सब लोग कर लेते हैं, EFA कर लेते हैं, CFA कर लेते हैं, बट दे आर लैकिंग बिहाइंड इन दिस. और इसलिए आपने देखा होगा 2-3 साल लग जाता है एक पेपर को आने में, इफ इम्पैक्ट फैक्टर ऑफ 3. सो इट्स वेरी डिफिकल्ट. जबकि आज बेसिक तरीके से आप इसको ब्यूटिफाई कर सकते हैं. सो सम एडिशनल इनपुट्स व्हिच आई थॉट टू शेयर विद यू. एजम्पशंस क्या हैं? इसके assumptions क्या हैं? बिकॉज देर इज नो एनालिसिस विदाउट एनी assumptions, राइट? तो फर्स्ट assumption इज नो आउटलायर. आपके डेटा सेट में आउटलायर नहीं होना चाहिए. आउटलायर में कोई ऐसा वैल्यू या कोई एकदम दूर का नंबर नहीं होना चाहिए अकॉर्डिंग टू द डेटाबेस विच इज नॉट इन द. अगर ऐसा होता और आपने डायरेक्टली रन कर दिया, सो दैट विल इफेक्ट. सो आपको assumptions लेके चलना है फैक्टर एनालिसिस में कि यू हैव टू बी श्योर अबाउट दैट नो आउटलायर इज देयर इन योर डेटाबेस. तो पहला नियम सबसे बड़ा नियम है. और आई थिंक ये फैक्टर एनालिसिस के लिए वैसे भी जरूरी है. अगर आप जनरल कोरिलेशन मैट्रिक्स बना रहे हैं, कंपोनेंट मैट्रिक्स बना रहे हैं, कोरिलेशन निकाल रहे हैं, आउटलायर तो आप समझ लीजिए इट इज द एनिमी ऑफ योर डेटा एनालिसिस. तो नो आउटलायर शुड प्रेजेंट इन योर डेटाबेस. इसलिए हम बार बार बोलते हैं डेटा क्रिस्प होना. डेटा कम हो चलेगा, बट डेटा ज्यादा है और कुछ और वेरिएबल है, दैट इज अ डिफरेंट स्टोरी. That I believe. I have different opinion about this outlier, right? Another is interval data. I think we have already interval data होना चाहिए, उसकी sequencing उस तरीके से होती है. Interval होना चाहिए डेटा में, gaps होने चाहिए. So like this, so interval data should be used for getting some great values in the factor analysis. Third is adequate sample size. Adequate sample size होना चाहिए. At least you have 230, 50 values, 300 values to use the factor analysis. अगर आपका data, suppose you are with 50, 60 values, then you can't apply the factor analysis because there is a possibility that you will get good gap in the data. Interval data में कुछ gap होना चाहिए. So adequate sample size is 300 plus or 250 plus, like more. अगर ज्यादा होगा तो चलेगा, बट वही मैंने बताया, ज्यादा मतलब देख लीजिए, श्योर अबाउट दैट आउटलायर तो नहीं. अभी देखा जाता है, many people come to me, sir, my analysis is not appropriate, please say. Then I found that so many outliers are there in their data set. And that's why the system is not, because system is programmed that way. तो ये कुछ conditions, assumptions, ये आपको करने ही होंगे, right? For this, no perfect multicolority. Multicolority नहीं होनी चाहिए, no perfect multicolarities है. Homoscedasticity नहीं होना चाहिए, linearity होना चाहिए. So like this, homoscedasticity होना चाहिए, no perfect multicolority. So these are the 6 assumptions. ये आप note करना चाहें या photo लेना चाहें आप ले सकते हैं. Assumptions for factor analysis. If every angle is great, these 6 angles are assumptions are great, then you are free to choose with this, right? So it is a procedure. अब थोड़ा सा समझ लेते हैं. It is a procedure to reduce a large amount of questions into few variables. तो मैं बहुत सिंपल तरीके से आपको बता रहे की कोशिश कर रहा हूँ. तो ये प्रोसीजर है, फैक्टर एनालिसिस का एक प्रोसीजर है, एक नियम कानून है रिसर्चर्स के लिए, जो बहुत सारे क्वेश्चंस को छोटे वेरिएबल्स में, छोटे क्वेश्चंस में कन्वर्ट कर रहे हैं अकॉर्डिंग टू देयर रिलेवेंस. प्रायोरिटी, रिलेवेंस का मतलब ध्यान दीजिए गाइस, प्रायोरिटी. और प्रायोरिटी कहाँ से बनेगी? वंस यू हैव डन लॉट ऑफ लिटरेचर रिव्यू. इसका कनेक्शन सीधा आपके लिटरेचर रिव्यू से. So according to the literature review, it is really important for you. Relevance नहीं तो आपको पता नहीं लगेगा. नहीं तो कुछ लोग आप किसी के पास जाएंगे, वो बोलेंगे आप मेरे हिसाब से तो ये होता है. But you decide, because it is your baby, your research paper, your research thesis, it's your baby. You decide. You have the full I should say, ownership to have this idea. You used to know how many dimensions a variable has. उनके dimensions कैसे हैं वो आपको मालूम होना चाहिए. एग्जाम्पल आप ले सकते हैं, ऑर्गेनाइजेशन सपोर्ट एंड सुपरवाइजरी सपोर्ट. किस तरह से सुपरवाइजरी मींस इंडिविजुअल सपोर्ट, ऑर्गेनाइजेशन सपोर्ट मींस द कंपनी सपोर्ट. मे बी यू डिसाइड बेस्ड ऑन दैट व्हाट इज द इंटरडिपेंडेंस टेक्निक. और फैक्टर एनालिसिस एक इंटरडिपेंडेंस टेक्निक है, बिकॉज इट विल गिव यू मोर आइडिया अबाउट द इंटर कोरिलेशन. जैसे हमने बात करी, रिलेटेड फैक्टर्स की बात की. सो दैट इज देयर. I think we are nearest to the end. These are the two different types of EFA, CFA. EFA का आप समझ लीजिए, the theoretical unknown. So dimension factors are theoretically unknown, जो मालूम ही नहीं है. तो अगर ऐसी situation है, then you go for the EFA. Or if your everything is under the control, means observed, then go for the confirmatory analysis. So confirmatory analysis is a statistical technique used to verify the factor structure of a set of observed variable. Observed variable है, clear है, सामने दिख रहे हैं आपको मालूम है आपको क्या करना है. तो CFA आपको आगे hypothesis testing and all these things which you can do and find this, okay, whether confirmatory analysis is applied. And exploratory analysis is where the theoretical background is unknown, right? So it is a technique, again it is a statistical approach to determine the correlation among the variables in a data set. And this type of analysis provide a factor structure, एक group का structure आपको बता देगा, which has the strong correlation. जिनका strong correlation है, तो उस केस में आप exploratory factor analysis use कर सकते हैं. तो these are some rules, but a very strong and fundamental rules, क्योंकि आपका पूरा research इसके ऊपर based है, right? So EFA क्या है? ये एग्जामिन करता है इंटर रिलेशनशिप को. तो ये काफी थोड़ा बड़ा प्रेजेंटेशन है. लेट मी सी इफ आई मेक द जस्टिस. तो मैं आपको जरूरी चीजें बता देता हूँ अकॉर्डिंग टू माय एक्सपीरियंस. Otherwise, again, it is an half an hour or 1 hour discussion about the EFA and CFA. EFA is quite popular because people are dealing with the strong correlation, as we have seen that. But इस केस में क्या था? CFA allows the researcher to test the hypothesis that a relationship between observed variable and their underlying latent construct, जो छुपे हुए underlying latent construct exist. तो उस केस में हम CFA लेते हैं जहाँ डायरेक्ट आ रहा है, ग्रुपिंग कर रहे हैं, बट फैक्टर की डायमेंशन हमें मालूम नहीं है. तो उस कंडीशन में हम EFA का यूज करेंगे. और अगर हमें पता है ऑब्जर्व वेरिएबल्स है, ऑब्जर्व वेरिएबल का हम कंस्ट्रक्ट के साथ कोई कनेक्शन देख रहे हैं, we go for directly CFA. So CFA is very easy because आपको कंस्ट्रक्ट मालूम है, आइटम्स पता है, लोडिंग आप दे सकते हैं, उसको बना सकते हैं. बट ईएफए के लिए थोड़ा सीक्वेंस है, दैट्स व्हाई ईएफए इज देयर. और जैसे ये आपके सामने फैक्टर एनालिसिस, फास्ट फूड रेस्टोरेंट, सो वेरिएबल्स क्या हो सकते हैं, वेटिंग टाइम फास्ट फूड पे, क्लीनिनेस, साफ सफाई, फ्रेंडली एम्प्लॉयज बिकॉज पीपल आर रेडी टू टेक योर challenges, taste, temperature, freshness, right? तो फैक्टर्स आप देखेंगे, सर्विस क्वालिटी के पैरामीटर्स क्या हैं, सर्विस, वेटिंग टाइम, क्लीनलीनेस, फ्रेंडली एम्प्लॉय. बट फूड क्वालिटी के पैरामीटर क्या है, टेस्ट, टेम्परेचर एंड फ्रेशनेस, राइट? तो ये एक मॉडल बन गया, आपके सामने एक मॉडल है और ये दूसरा मॉडल है. सो दिस मॉडल इज फैक्टर के बेसिस में वेरिएबल्स क्या है, फूड क्वालिटी के वेरिएबल्स है टेस्ट, टेम्परेचर, फ्रेशनेस. सर्विस क्वालिटी के वेरिएबल्स क्या है, वेटिंग टाइम, क्लीननेस, फ्रेंड. सो दीज आर द फैक्टर एनालिसिस टू ए फास्ट फूड रेस्टोरेंट. तो इस तरह का मॉडल बना लेते हैं और मॉडल को हम टेस्ट करते हैं. मॉडल मीन्स द सिचुएशन. तो इसको डिसीजन लेने के लिए हमारे पास एक प्रॉपर स्टेज का सीक्वेंस है, डिसीजन प्रोसेस है, ऑब्जेक्टिव्स हमें मालूम होने चाहिए, डिजाइन मालूम होना चाहिए, assumption I have already explained you, deriving factors and assessing overall fit, कैसे बराबर आ रहे हैं कि फैक्टर नहीं आ रहे हैं, interpreting the factors, validation, factor analysis. Validation means to verify whether a factor analysis and additional use of factor analysis result कि आप उसका कैसे यूज कर सकते. So that's a decision process. तो ये थोड़ा सा आपको बता देते हैं, ऑब्जेक्टिव, एक्सप्लोनेटरी, कंफर्मेटरी, स्पेसिफिक ऑफ यूनिट ऑफ एनालिसिस, डेटा समराइजेशन, रिड्यूस कर रहे हैं, आप डेटा को समराइज कर रहे हैं, छोटा बना रहे हैं, उसको रिड्यूस कर रहे हैं, कम कर रहे हैं, दोनों में अंतर है. कभी कभी हम दोनों करते हैं, दैट्स व्हाई वी यूज एंड. यूजिंग फैक्टर एनालिसिस विद अदर टेक्निक्स आल्सो इट कैन बी डन. डेटा समराइजेशन में क्या करते हैं, डेटा रिडक्शन में क्या करते हैं. सो दीज आर टू डिफरेंट थिंग एंड दिस इज अ वाइवा क्वेश्चन आल्सो. मेनी टाइम पीपल, प्रोफेसर्स आस्क difference between, are they same, are they different? So your answer should be these are different outcomes of factor analysis. Baki EFA again is used to discover the factor structure of a construct and examine its reliability. It is a data driven. Or confirmatory analysis, it is a theory driven because here you are considering the hypothesized factors. आप कुछ assumptions ले रहे हैं, right? Designing a factor, उसके basis है, calculation कैसे करना है ना, डिजाइन कैसे बनाना है, सैंपल साइज नेसेसरी कितना होना चाहिए, एज आई ऑलरेडी गिवन टू यू. How to run this, rule of thumb, factor analysis, perform sample size, sample must more observed value than variable. Minimum absolute sample size should be 50 observation. But अभी आजकल जो देखा जा रहा है, because variables are quite close, so we recommend at least you have data set not less than 150 or 200, right? Because you will get good results and differences, right? Baki R versus Q analysis, assumption of factor, I think we have already discussed this part. Multicollinearity, essays using MSA, measure of sampling adequacy, KMO test, KMO Bartlett test is there, homogeneity of sample factor solutions are also there. So these are further assumptions just to check about the multicollinearity and homoscedasticity. And testing assumption of factor analysis, use Bartlett test of sphericity is there because sphericity is rotation. It is based on the rotation of the. So Bartlett test will give you significant, at the level of significance less than 0.05 पर हम measure करते हैं कि वहाँ पर है कि नहीं है. तो वो हमें ये सब मशीन में है आपकी. तो you need not to worry about this, but थोड़ा आइडिया लगना चाहिए. That's why this is there. क्योंकि आप judgment ले पाएंगे. Okay. So MSA value must exceed 0.50 for both overall test and each individual variables like this. So in this way, I think number of factors, late root and criteria, these are further, discussion topic, So priority criteria, percentage of variance, कितना होना चाहिए, क्यों होना चाहिए. कुछ इस तरह का plot आता है, Sikre plot बोलते हैं इसको. Sikre plot, which is based on the latent root eigenvalues versus the factor number. कितने हमने factor लिए, कैसे लिए. तो उसका graph हमेशा ऐसे ही आएगा. So this will give you the test criteria. इस ग्राफ को भी आपको अपने पेपर में दे सकते हैं. मैंने काफी पेपर्स देखे हैं which they are not giving this graph. तो उससे पता लगता है आपने फैक्टर एनालिसिस पूरा नहीं किया. Please give this graph in your whenever you are using factor analysis. These are the other rules which I think because of paucity of time not able to cover up. So this is the rotation, orthogonal factor rotation and all, and what is the rotation, कितने value पे कितना intercept आएगा like this. But it is very easy. You can refer any textbook or any material. Probably it will help you about this. Because you remember I was mentioning somewhere about the direction. So this is a vector direction. V1, V2 are the vectors. Remember or not? In the beginning. कितने angle पर कितना deflection आ रहा है वो सब हम measure कर रहे हैं because these days techniques are there, right? So that's why. But if you talk about the 30 years back, there was no software, nothing. People were not using it. But these days, everything is there. So that's why the editor's expectation, people expectations, good, more, and these things are required. So I think I am done with this part. I hope you had some bit of learning. कुछ समझ में आया होगा. Otherwise, it's a very highly loaded topic. But I have tried my best to give you some concept. ये थोड़ा सा आप देख लीजिए. परफॉर्म कैसे करते हैं सीएफ पे, तो एबिलिटी, एस्पायरेशन, इसके वो मॉडल वैसे मैंने आपको बता दिया था. आइटम 1, आइटम 2, आइटम 3. आई थिंक इट इज द सेम केस अप्लाइड हियर विद द अदर एग्जांपल. And CFA in similar term, EFA is some small respect. Philosophically, it is quite different. क्योंकि दोनों different है. EFA, CFA quite different, but the SEM is then applied to test the extent to which the researcher loading. आप बस वेट्स देते हैं, ऐसा कुछ स्ट्रक्चर दिखता है, आपने पेपर्स में देखा होगा. सो इट इज नॉट वेरी बिग डील. इसमें बहुत कुछ नहीं है. छोटे छोटे मॉडल्स बताने हैं आपको, उसके लोडिंग्स को चेक करना है, उससे रिलेटेड हमारी हाइपोथेसिस है. मुझे जो वैल्यू मिल जाएगा, मेरे को हाइपोथेसिस का रिजल्ट मिल जाएगा. तो ये लेटेंट वेरिएबल है, इंडिकेटर्स है, ये एक मॉडल है. सो मेजर मॉडल, इंडिकेटर, रिलेशन बिटवीन द लेटेंट वेरिएबल, उनका कैसे कनेक्शन है. जैसे बिहेवियर इंटेंशन का कनेक्शन, इंटेंशन पर इंटेंशन 1, इंटेंशन 2, इंटेंशन 3, but it has a connection with the hypothesis 1, 2, and 3. But hypotheses are based on some variables, right? So which are the variables? Performance expectancy, effort expectancy, social influence, and facilitation condition. और ये factors हैं, ये different factors हैं in different. So it's a model, it's a one situation like this, and you can decide. So with these words, guys, thank you very much. So I hope you had a good learning. I think our flight is landed on correct time, if I'm not wrong. So if you have any queries, you are free to choose. I hope you had a good journey, guys.
Yes, sir.
Yes.
Yes, sir.
Yes. कुछ समझ में आया? I have tried my best within this time of 1.5 hours. You can share your feedback also. This is my email ID. Please note down. Any questions, guys? Dr. Farhan, Dr. Satyajit, other participants.
Yes, sir.
So I'm done with the session. If you have any specific query, I can wait, I can address. I'm sorry, Mr. Farhan. Very good. I have tried my best क्योंकि कुछ बेसिक से लेके जाना होता है because we have all sorts of people, maybe experience, maybe less, but I always go with the fundamental, and whatever we are doing, we should be explicit. It is not hi-fi. Otherwise, randomly people are applying these techniques. If you ask them, then they have very no answer. And they generally say, sir, my guide, my committee told me, that's why I have applied. So such responses we get. So I request all the people to follow some good literature. I will mail you, okay? And if you need this handout, I will mail to Dr. Satyajit. Dr. Satyajit, you can share or you can add me in some group. I will directly share other material also directly.
Sure, sir.
If you have some group, you can add me there. So then probably it's a starting journey. And
Sure.
Yes, Shruti, we use PC and ANOVA during EFA, Principal Component Analysis. This entire discussion was on ANOVA. And ANOVA is not a very basic exercise. It also varies from context to context. Shruti?
Sir, actually, you were discussing about the factor analysis. So I think so PCA comes under the factor analysis.
Yes, PCA is a part of factor analysis, but ANOVA is attached to that. Because you said na, when to use PCA or ANOVA. So
Wait, can you give some specific cases like?
I've already explained. You can take some example, that example which you can recall about the behavior aspect. So where many latent variables are there, hidden parameters are there. So under those circumstances, factor analysis is much needed. Because the idea is that you are not eligible to go superficially and evaluate and prepare the correlation matrix. The idea is that you go to the hidden constructs and hidden variables. I think I already addressed this part during my session.
Okay, sir.
So that's why factor analysis is important, and that's why, due to the whole reason, tomorrow I will give you one chart also. Probably I today I forgot to brought that. So it will give you the clear-cut picture when to use, how we are using, when are you using these multivariate techniques.
Sure, sir.
Okay. Haji.
Sure. Thank you, sir.
Okay, ji, welcome.
Thank you, sir.
Thank you very much. All pleasure is mine. And I request the organizers and participants, can we have a small photo as a memory? With the permission of director.
Sure, sir. Sure, sir. Sure.
Yeah, thank you, ma'am. Thank you. Because I'm not sure whether Dr. Farhan has taken the pics or not. I do not know.
Done. It's done, sir.
Okay, thank you.
Please share it with sir.
Yeah, please share.
Please.
Okay, thank you very much, ma'am.
Thank you, sir. Thank you.
For
Sir.
all the blessings. Okay, thank you.
Thank you, sir. Namaskar, sir. Okay. Biswas sir is there, Satyajit. Namaskar, sir.
Namaskar.
So it is 3.
Good afternoon, sir.
What time in the night, sir? 3 o'clock?
It's 3, around 3. Yes.
My God.
3:10 in the morning.
Oh my God. 3 in the morning.
Yes, but no problem.
No, sir. Thank you very much, sir, for giving this time. It is, sir is in the US, Satyajit. Pata hai na aapko? And it is 3 o'clock in the morning at sir's place. Okay, so introduction, I think Farhan is doing. Huh? Farhan,
Yes, sir. Farhan, please.
Thank you, Farhan. Thank you, Dr. Vandana, Satrajit, and welcoming all the participants. Since it's a little late in the evening, my voice may be a little hoarse, but pardon me for that. So what I'll do is I'll share my screen
Yes.
because I have, jotted down a few points. No, this is not what I want. Okay, let me know if you can
Yes,
read
sir.
it.
Yes,
Is
sir.
it readable? Okay,
Yes, sir.
great.
It's coming. Yes, sir.
So this is the theme on which I'm working. I was looking at, the background under which this course has been held. It was interesting to see that, there are topics that relate to management. There are topics which relate to a lot of statistical stuff. Okay. And also about some humanities thing which talk about psychology, philosophy, and so on. And in this midst, 26th May, I have this research in CSE where I stand today. So looking at the context in which you people have been exposed to so far, mine is a little different in the sense that my focus will be on computer science and engineering, though I would like to touch upon some basic ideas in research also. It's very exciting and interesting. So I go back to my opening slide. Firstly, some disclaimers. So while I do with computer science and engineering, please do not expect some absolutely new material from me, because this area is well researched. A lot of people have written a lot of articles from different perspectives. So there is nothing, completely new that I can bring about. But what I would like to do is written out here, that I'll give you my perspective, my feelings, okay, and my view about the research in computer science and engineering that started from the day I started my research in 1975 till whatever is the time date today. So I try to put in my perspective to the extent I can. The facts will remain the same, but the viewpoint may be different. So this is the background, my experience at IIT Bombay Computer Science Department. And for a brief stint in 1992-93, when I was in the Center for Supercomputing Research and Development, University of Illinois at Urbana-Champaign. So all of that is packed into what I'm going to tell you. It will not be too deeply theoretical because that is not the intent. The real purpose is to enthuse young researchers to come to computer science and do some research there and get the benefits and the satisfaction of doing something interesting. So firstly, we all know that research is a very creative activity and there is no known algorithm that can be applied to create any new thing or to invent system, an algorithm, theorem, whatever. So what we know is the path for research. That is somewhat well understood. Or I should say the paths for research. There are many ways you could go about it. And I'll touch upon some of these in this particular talk. So I have decided to limit my scope of this talk to how to conduct research in general, and particularly in the area of computer science and engineering. And I'm going to add a context very soon, not a general research in CSE, but probably with a given context, which I think is more appropriate for the audience of this particular program. So in the process, I may give you some simple guidelines which I feel are easy steps for getting initiated into research. So all the young researchers or all those faculty who want to switch to a new area may find the guidelines somewhat easier to adopt. The key idea is whatever we do in research, we would like to sustain quality. That's very important. And we know that the BIT institutes are known for, have been there for a long time, and they have done some quality work. You would like that to be sustained, continued, enhanced. And as a teacher, I always believe that ideas are communicated through examples, good, well chosen, concrete examples. So I have put much of that into this talk wherever I could find an opportunity. So there is a scope, the 4 bullets as you can see. And with this background, let me delve directly into the theme. So firstly, even if I get into domain of CSE research, I first want to set up the context. And my word context sensitive is something which we like very much to use, being a compiler person, context free grammars, context sensitive grammars. So I start very quickly of 1 or 2 minutes each on different types of research which are happening in computer science and engineering in India or abroad. So I first start from abroad. Now, these are the industries and the well-known research laboratories which are in the private sector. Google, Microsoft Research, Apple, Intel, Amazon, IBM Research, these to be Bell Labs, NVIDIA, whole lot of them. There are many, many more which I have not listed. They do outstanding research, and most of us are familiar with their products. We use them daily in our day-to-day life. If you want to characterize the research that goes on out there, which is also in computer science and engineering, are by far creation of new products, which have a lot of R&D in them. Okay, the product that we use or we keep on using as we go along. What is the distinct about them? They have very well-defined research agenda. Of course, which are very strong commercial implication because they have to make money, which is in sync with the products that they are built or they are building in the future. So their research agenda is very, very clear. More importantly, they have thousands of well-qualified PhDs and MSs from all over the world. Very, very qualified, competent, technical resource. Google for sure, even others have it in large numbers. So have the critical mass. They have several research groups, many working on present day problems, many working on problems of tomorrow. And of course, they have deliverables all the way. Very strong infrastructure, the best of the research facilities, large funding for research, excellent pay and perks, and of course, they collaborate heavily with academic institutions. So the research that they do is the research for the future, and even the best of the organizations in India will nowhere be close to what they do. So this is model number 1. This research is of a different class altogether at a different scale. It's good to know what they do, but they are not the model that we can imitate. Very quickly, then let's go out to the university research in the academia. So if you go across the world, Carnegie Mellon, Berkeley, MIT, Cambridge in UK, Stanford in US, Tsinghua in China, Munich in Germany, NUS in Singapore, these are some of the well-known universities which are also doing reasonably high amount of research. Some of them are absolutely top class. If you want to know their distinguishing features, I'm sure you know. Let's look at that. Very strong academic programs, starting from the undergrad to right up to graduate level, which includes their masters and PhD. Not only that, they have a large pool of very bright international students from all over the world, all these institutions. So they have a very strong human resource as from the student point of view. They have significantly high number of qualified, competent faculty. Maybe less than the research laboratories, but still they have the critical mass in terms of very highly qualified from the best of the institutes with industry experience or without industry experience in the computer science and engineering departments. They work with a lot of dedication. They form specialized laboratories. They create centers of excellence in which they do absolute frontline research. In the process, they have very good infrastructure. So again, they are a class apart from most other institutions in the rest of the world. What is their strength? Large funding for research. They have a complete hierarchical structure for research. Faculty, full-time, tenured faculty, lots of postdoctoral fellows, large numbers. The number of postdoctoral fellows could be half the faculty strength usually. Large number of research staff, full-time research staff, and of course, very high quality PhD students. So human resource is very strong, facilities are very strong, they are well paid, well taken care of, and therefore they also perform at a different level. The fundings are way different than what the fundings are in the other third world countries. They have very high collaboration with the industries. As a result, they work on live problems. Okay, they don't have to hunt for a research problem. Problems come to their desk. Okay, the companies will reach out to them and tell, okay, this is a problem, can you solve it? And they don't solve the problems of today, they also solve the industry's problems for tomorrow. And they get a lot of funds for that. Their deliverables are very high. They have very high quality publications, lots of patents. They create research tools, research products which are used in the academia, and they deliver both in quality and quantity. So this is model 2, which is also very different than ours and very difficult to match, including the best of the institutions in India with what these people are able to deliver, create, and sustain. So while it is good to know them, they are of course not replicable. I come down to the Indian counterpart. We also have a lot of laboratories and industries, sponsored laboratories, mostly in the government, but there's some in the private also, like the HP, the General Electric, or Intel in Bangalore, and some others do have research and development activities. But mostly they are in the government sector. Bhabha Atomic Research Center, there's some computer related activities. ISRO does, you are well familiar with. Space Application Center, Center for Development of Advanced Computing, a lot of CSIR labs, National Aeronautical Laboratory Bangalore, which developed one of the earlier supercomputers, Defense Research Labs, the Indian Institute of Remote Sensing, and so on. So there are very well defined labs in the government, mostly in the government, to do a lot of R&D efforts. So they are set up for specific objectives, some applications in mind. They have very clear defined research agenda, and they are very dedicated people. We know, for example, the good work that ISRO has been doing over the years. It is extremely visible and relevant to the nation. They have some number, I wouldn't say very high, but they have a number of qualified, competent technical people, mostly from the best of the institutes. They also send their people to other good organizations, universities for training. They do give good deliverables. Okay. They have good infrastructure in the area of their interest. They do a lot of indigenous research. Funding is ample, though they may claim that that's not enough, but generally the government funds them handsomely, and they do collaborate with academic institutions. They take interns, for example, they'll come and sponsor projects in the academic institutions. So they are doing well, but they have very definite agenda, and their model is not replicable for us, because we would like to do research in Indian academia. But we could borrow some skills from them because they're good at it. Now, very quickly, let's go down to the premier institutes, IITs, Institute of Science, Tata Institute, NITs, triple ITs, and so on. If you want to characterize them, they have strong programs at the UG level, fairly good strong program because they get very good undergrad students. Their graduate programs are okay, sort of improving, but nothing of the scale that is required or present in other places. We have very few international presence, both in the students and the faculty. So we are more national, but we are not really international. We have highly competent faculty, many definitely in the IITs, and also fairly qualified, competent faculty in the others. But the numbers are not commensurate with the expectations which the end user has on us, all these institutes. And our mandate is to do high quality teaching, create human resources which are good across the board at all levels, undergrad and graduate level. They have set up research groups with specialized laboratories. We have, I would say, decent infrastructure in some of them. There is full funding for research. Postdoctoral fellows in low numbers are present. Research staff is funded. PhD students are paid. MS students are paid. So we are definitely better off than many other institutions. So there is some support for research at the base ground level. And these institutes generate a lot of resource by virtue of their sponsored and consultancy research. They collaborate with industries. They do a lot of continuing education programs. Hopefully, they do some quality teaching for other institutions in the form of NPTEL. And they do some deliverables in terms of publications, patents. But again, the government feels, or the end users feels, the society feels that the deliverables or the output is not commensurate with the funds which are made available to them. So in a way, they feel, and probably they are right, that these institutes also are somewhat underperforming as compared to their capacity. So this is a situation at the premier institution level. Now let's come down directly, instead of wasting any more time, to the undergraduate engineering institution that we are looking at, like the BITS Pilani. There's some research, but primarily teaching. BIT Mishra, Thapar, Manipal, and many others. There are others who do not even do research in undergraduate, so I'm leaving them away. So we would like to look at this group of institutions who do undergraduate engineering programs. They have some graduate programs, and let's see what are their characteristics. So these are very personal view. You may dispute and you may not agree with what I'm saying. So I would say they have good academic program at the UG level. Standard syllabus, EICT or whatever. There's a continuous attempt to improve teaching. They have graduate programs at some level. I won't say they are very strong, but they have programs which are not very well subscribed. They may not get the students that they want. Undergrad students, at least in computer science and engineering, are probably the best in the campus of all of these institutes. Faculties, they have qualified faculty, but probably not enough, as many as they want. Okay, many faculty have PhD, and the mandate of the institutes are to first do quality teaching, so that the output, the students are able to be absorbed in the best of the companies and they do well. And subsequent to teaching, they're supposed to do research and all other things that the other institutes do. So these institutes have decent laboratory for undergraduate teaching, but if you want to see research facilities at the high end, they are not present in large numbers. They also require a lot of funds, which will not come to private institutions easily. One of the distinct characteristics, in my opinion, and this is what I have seen happen, both during my interaction with institutes in the belt of Maharashtra, and also now that I have joined BIT Mishra and visited the campuses, that the commitment of teaching is heavy. And the commitment without support for evaluation and other things which other institutes have, it becomes heavier. Funding for research and PhD students are not great to speak of. So there is a struggle out there on this particular front. Limited collaborations with industries. Industries are not very forthcoming to come, and therefore it requires again a lot of effort to build up bridges with the industry, either in the public or in the private sector. Okay, so and there are not too many computer science and engineering industries in the belts that these institutes are situated, as a reason for which such collaborations are not easy. So I have decided to focus my talk on this group of institutions. The others are pretty well off, relatively, and they can take care of themselves. But these institutes who have to do research now, the mandate is clear. Besides teaching, how would they go about doing it? They're doing it already, but is there a way to ramp that research up and to do better? Okay. So with this, I have sort of given you the context in which most of this talk will happen. We are talking about institutions. We do not have too much facilities, who may not have large number of PhDs. Faculty members are few. Students are good to average. Resources and facilities are minimal to sort of satisfactory. And in that context, we have to do research. So first, let us quickly review from in computer science and engineering. I wish if there are people who are sitting from different disciplines like management and others, okay, if they're not able to sort of appreciate what is going on, it's because now it's getting a little technical. So since I joined research PhD at Kharagpur in 1975, we had these 4 areas. They were traditionally called hardware. So people may do some FPGA-like stuff. Somebody may build design caches. Somebody may do some profiling of the architecture. Okay, and so on. So their architecture and hardware was supposed to be in one basket, and there were a set of people who were doing problem solving in this area. The problem still exists. Hardware has become much more powerful, much more versatile. Architectures are very, very challenging. And this research area is still very much alive. Okay, only the problems have become more and more complex. And there was system software. Software was divided into application software and system software. And people who used to build systems, assemblers, linkers, loaders, other tools, they all happen to belong to this domain, which is called system software. In the earlier days, building compilers for new languages, for new machines was itself a challenge. Today, these areas are sort of well understood. However, optimization of the resources used to design these tools or softwares is still not well understood. Compiler optimization, the area in which I work. Okay, I started in 75. You can see how many years have gone, and still people are struggling to develop compilers which can deliver or produce target code to the same capability as a very advanced, intelligent human being can do. Operating systems still have bugs. They crash quite often, and so on. So foolproof system software is still not in place today. And there are research issues which have to be sorted out before it reaches the last mile. So these areas are not dead, but since a lot of research has been done, it is more difficult to start and create new idea or a new result in these areas. Traditionally, application software was database, image processing, graphics, vision, artificial intelligence, signal processing, and so on. Many, many other such things. The application areas thrive today. All of these are relevant, except that the research issues have become deeper. TBMS, somebody might be doing query optimization or might be getting into distributed databases. Image processing or graphics and vision have got extra complexity because of the power of the hardwares, the speed at which things come, okay, how to recognize things which were way beyond what was expected yesterday. AI has grown in a huge way. So all these areas remain even relevant today, but the problem shapes have become different. Theoretical computer science people used to work in algorithms. Forgive me for the spelling, I can see an error there. Complexity, okay, automata theory, formal verification, approximation algorithms, randomized algorithms, and so on and so forth. Still, the areas are very much alive, but again, the problems have become far more complex. So the traditional areas are there, and as I'm going to say a little later, that probably if you're going to start a research in computer science today or tomorrow, maybe these 4 traditional branches should not be looked at or picked up for your research. So the new areas, lots of them. Internet of Things, for one, there's no order of priority. These are some of the new areas. They are very interdisciplinary. The Internet of Things, as you know, there are a lot of sensors, and you could monitor anything that you want. Lots of phenomenon. Okay, the sensors have to capture data. The sensors have to communicate among themselves. There may not be any network bandwidth issues. So there are a lot of issues which have come up in this domain for which research is going on in a very active footing. Because a lot of data is getting generated, okay, whether you are doing it through your social media or you are getting it from Internet of Things and so on, data analytics is another good research area to work on. Okay, so people who love data, who would love to analyze raw data to detect trends, patterns, predict, and want to predict things, the way things will happen, this is the area to work on. A somewhat similar but orthogonal area is data science. Again, there are a lot of opportunities today in data science, both in the job market as well as in the research field. Large number of problems are there which deal with the issues that I've written over there. How to build data sets which are clean, reliable, how to use algorithms or create algorithms, develop statistical models or learn statistical models to convert the data to a form that is more readily usable. Again, the readily, there's a spelling error over there. Machine learning is a relatively new area, and it has already gone into several deeper variations where the motive is to try to understand, look at lots of data, huge amount of data, okay, and develop algorithms so that they can learn from data with or without help from human beings and imitate the way the human learns. Very, very interesting area. Lots of applications, except that people still do not understand how many of these techniques work. It's difficult to find a reason why the methods work, but the methods, developing the methods or developing a model is not so difficult. A lot of research is possible in this particular area. Security is another new area, not so new, but a lot of focus right now because of the way computing has pervaded all our lives. Okay, so there is security of the information or the data, security at the system level, whether it's a mobile or a bank or any other organization. It's a very, very important issue. And therefore, there are a lot of research problems that people are dealing with in security. So as much as security research is going on, people are also aware of the breaches in security which is happening at a very, very high level. And we know the risks that are involved if some security at the highest level are broken, which can be catastrophic for us and can hurt us in a big, big way. So this is another very promising research area, and the problems are challenging, interesting, and so on. High performance computing is another area which is picking up slowly now. The hardware came up long back. Okay, so there were single core machines earlier. 2 to 3 gigahertz with frequencies. But the hardware designers could not increase the frequency anymore because of limitations of physics. So what they went is they did design multi-core hardwares. And the multi could be really multi, thousands of them, okay, like the GPUs. Now, while the hardware is very much existing, it is not easy at all to use these hardware to solve today's problems. So there is an issue. This is the area in which I work. I, for example, work in the area of converting sequential programs to automatically parallel forms. Okay, so that I can use multiple cores. You give me a normal sequential code and I can convert it to a reasonably good parallel code without any loss of precision or the result output, and still run on the multi-core and get reasonable speedups. So developing system software, developing application software in high performance computing is a big deal in many areas. So these are, so you can see that there are a lot of research areas in which one can work. Good to know. Okay, but then how does one start? I'll slowly get into that. So first, the observation is, which I told you earlier, it is relatively easier to undertake research in emerging areas as compared to the traditional ones. Don't mistake, it's not as if the emerging areas are very different. The skills that are used in the traditional areas are still used in the emerging areas, but the skills are now more multidimensional. Okay, so multiple domain skills are required now in the emerging areas. You cannot just know, for example, one particular area, AI, and then get away. You'll have to know many more layers to solve problems in the area. And what is the basic reason? A lot of research in the traditional areas. So as people say, all the low-hanging fruits are already been picked up. What is left are very high up in the tree. So it will require a lot of effort to pick those fruits, but then they will be very big discoveries because they are the harder problems that remain unsolved over the last 4 or 5 decades. So tough problems will give you a lot of importance and visibility, but not advisable for a fresh research person. But in the emerging areas, since a lot of work is happening, there are a lot of low-hanging fruits. So you could do reasonably good research and get a PhD, okay, with hopefully relatively lesser effort. That's my personal view. I should also tell you that very few people in the industry or academia that I know have deep internal knowledge in either the traditional or the emerging areas, whether in systems or theory. So you won't find too many people who can actually take an OS kernel and redesign it, who can optimize the compiler by you adding a new pass over it, do parallel computing, AI, ML, whatever areas you're talking about. Okay, so deep knowledge of any subject is still not available in large numbers. So if you develop a good knowledge, internal knowledge of any area and its systems, you are a person who will be of great demand. Okay, so this is the general scenario. Now coming down to the problem at hand, what do we think? I'll again talk about it at the end. How do we do feasible research? UG engineering institutions. I presume most of you come from these institutions. So this is my observation. Maybe some of you will have a better idea or a better theme to work on it. I feel that the energy of the motivated undergraduates, who may not be in large numbers, even if I assume 25% of your undergraduates in CSE are willing or sitting on the fence, and if you can motivate them to do good work and add them to your research agenda, that will be very valuable. We cannot afford to let go the energy of the some of the brighter undergrads who are capable of delivering things in research, not just in teaching and learning. Since all of you are short of the critical mass in terms of faculty strength, it will be very unfortunate if everybody sort of forms into a different area. It will be very difficult to deliver anything substantial. So with mutual consent, if a few areas could be identified where people would work together, then you have good chance of getting success in research in those selected areas. Now for quality, it is very important that we do right from the beginning. We first know how to identify quality. Then we'll dig deep into the research articles, whatever other resources are available, and maybe in group or otherwise with the students, try to consume this material and form our own handouts, notes, which show that we have understood them well. I strongly feel that faculty, those who are research minded and want students to come and join their group to do research at whatever level, even undergrad students, the onus is on us to create short modules of essential skills that are required for research in your area. It could be an exposure to a tool, it could be exposure to some mathematical concepts, whatever. It could be exposure to some programming languages which are specific. All that has to be given to the students in a very short while. So short modules, and it has to be done by the faculty who wants to hire these students. The next one is similar. Installation of research tools and open source software. You should do in the area that you are working on. And there are excellent tools in the domain. And let me tell you some of the tools that I use. There are not many people in the world who would know how to use them meaningfully. Using is one thing. And to take the tool, make internal changes to it so that I can use it for my indigenous research as a byproduct requires a different level of commitment and time. If you can do that, then this expertise is invaluable. Even the industry people, many of them don't have it. You will have to establish contacts with external world. I'll give you some tips in the next few slides as I go along. It has to be done. The external world could be people around your institution, in the same city, in the same state, in the country, or even outside. Okay, it is not easy to do so. If you do in an ad hoc way, it will fail. People will not respond. So how to go about doing this will have to be learned, and sort of cultured on to do this. And the last point is that we give a lot of projects to students. Most of them are wasted because they don't come out with anything substantial. So how do we utilization issue be controlled or reduced? Because then a lot of our time and effort goes into those things. So projects that we design, that we think should become ready and available at some point in time if I keep sustained efforts in designing it, delivering it. It could even be a theory. It doesn't matter what we are looking at. So according to me, these are some of the things which are available with us. Motivated undergrads, some numbers, many faculty who have PhDs and have some research interests, how to put them together, how to first go and read quality articles. This is very, very important. Quality articles requires a certain maturity and background. And if we don't have it today, we must go and acquire them in some point in time in the near future. So firstly, since I'm not able to see the screen, if you are giving a chat, if you have a question, you can interrupt me and you can ask, and I'll be ready to answer in whatever manner I can. Here is something I would have loved to do in person out there, had I been there at PIT Lalpur, and had you all been present physically in person, but still I'm trying to do it in a offline manner, in an online manner, and this is the way I would look at quality in a research area. So purposely I have not picked up my area which I know well, and I'm looking into areas which I'm not very conversant with. Let's see how do I do this. So this is the way I would go. There are two outstanding publications. One is called ACM Computing Surveys, which is there on the screen, and the other one is called Computing Reviews. Both of them are good. I like this, so my bias is to the computing surveys. So what do I do? First, you observe, even if you don't have institutional membership, it doesn't matter. This is a resource which you can use directly from your Gmail address. What do I need to do? So what I wanted to do is, there are lots of issues. Every quarterly, an issue is coming. But I wanted to see what is happening today. Okay, so I went to this site yesterday. I thought I'll do it on the fly, but network, bandwidth and connectivity could be an issue. So I did it yesterday. So I went to this journal, ACM Computing Surveys, and I went to this place where they had this is from the journal site. The articles are recently accepted to the journal, are correctly in the production process, which means they will appear in the near future. They are still not appeared in the journals online. Something is there. So the accepted manuscripts we can view, we can read. Okay, and if you want to cite them, they have also given some sort of a tag which you can use to cite these references in your articles, whatever you write. So let's look at how these structured goes. This is my way of looking at it. So first they tell you whether the survey is free or it is paid. So these are all free. The name of the article comes here: file packing from malware perspective, techniques, analysis, approaches, and directions for enhancements. This is the topic. These are all survey articles, remember. There are 4 authors: Muralidharan, Cohen, Gerson, and Nissim. Okay, it doesn't say where it is, but it tells you it was accepted in April 2022, just last month. Okay, and they are giving you some index number. And after that, they give you a short description of what is there in the paper, very few lines only. This is what you see on that site. Coming back, some idea about when the fact it was just accepted. For old papers, this will not be there. The title of the paper, survey article, the name of the authors, no affiliation, date or month of acceptance, some number, and a very brief few lines of description about what this paper does. So what I did is, there are lots of papers out there. I downloaded many of them, and I'll pass it down to as a part of my course material. But I want to show you what I have done and what you could also do if you are trying to work in some of these areas, if you're interested. So the name is file packing, malware perspective, analysis approaches, directions. First, note some important information which I put out for you. It's a 41-page article, not small. It has got 128 references, fairly large number of references who are people who have worked on similar topics or in this broad area. Okay, their affiliations are not here, but if you look at the downloaded paper, you will see from where they are. You can see there are 4 authors. Many of them are from different institutes, different countries. The area in which this particular paper applies, this is some are my labels, and some are from the papers themselves. They are in security and privacy area, broad area. Look at the second one: engineering blockchain-based software systems, foundations, survey, and future directions. This has 46 pages, 74 references, and I can't count. There are just far too many authors over here, including an Indian, as I can see. More than one Indian, Aditya Ghosh, Anuradha Gunawardhana, and so on and so forth. Maybe Sri Lankan, I don't know. So a large team writing a fairly large article, accepted in April 2022, will come in the future publications. The area is software engineering and blockchain. Okay, so if you look at it, these are all, I'm not going to go through each one of them because that's not the point. I'll pass you these slides so you can look at them at leisure. The next one is on security using hardware. So a lot of security solutions have been done through software. These authors wanted to know, have people tried hardware solutions for security? Because software can always be broken. Maybe the hardware is not easy to break. So, and they have found that there are 125 people who have already worked in this area. Okay, and you can again see it's a multi-authored paper. So many different people. And if you go to their exact references, their exact affiliations, you will see which universities or which places they came from. The next one is from database management system, indexing and querying. Okay, but they have something called similarity search. And again, there are a lot of authors for this paper. 37 pages, 156 references. So now I'm going to run down without going in more detail. So this one is on biometric security and privacy area. Something to do with image quality assessment, December 2021. Cryptography. The next one is on incomplete data, IoT, machine learning, computer vision, AI. I was trying to pick up different areas. I think altogether there were 25 survey articles that they have recently accepted. Evolutionary algorithm, multi-objective optimization, reinforced learning, deep learning, and many, many more. You name an area, it is almost something is there. So why am I suggesting this? Firstly, because it's a fairly reputed journal. Okay, so I wanted quality reading material in a research area in which I have already identified, or let us say I have not identified, and I want to know what are people working on today. So this tells me there are some areas in which people are working. So if I'm interested in machine learning, I probably would have looked at some of these deep learning, reinforced learning, other problems and gone into those papers. Okay, so from this exercise, what I'm trying to tell you is that you get a clear idea about the title, you get to know the focus, you read the abstract, you know what exactly is the person trying to do. You look at the author and the credentials. Why? Because maybe, the quality of the paper will further depend on from where the paper is coming up. If it is one of the established institutes, research labs, universities, well-known researchers, then it becomes more reliable as compared to others. Usually all survey papers are big. They give you large number of references. So this gives you a good repository or a good starting point to identify your interest or to read papers in that area. It's not going to be easy. To read a 40, 50 page article which has 120 references, you have to do more data mining. Because otherwise it will take a long time. You'll be reading it for years. That is not the idea. So what I should do, I should then probably judge by looking at the authors and the credentials. If there are 125 references, can I cut it down? Should I read all the 125? Very, very unlikely. No time. So what do I do? What do you do? So I will look at the list of references. They were too big, so I could not copy it out here. Then I look at the people. Okay, and I can get a lot of other information from these, from the details. For example, if you look at the references, you will find that there are some research groups which are heavily writing papers, maybe from Switzerland, maybe from Zurich, maybe from India, France, maybe from MIT labs, whatever. So you immediately get to know people or the institutions who are doing heavy research in that area. That's a good information. You will also see that there are some which are very small extensions or simple ideas. So you can sort of leave them for later reading and concentrate on those papers which are more classical or which have more information. So classifying the references and reading a few of them to get a feel of the area in which lots of work has been done is a very good starting point. And if you can, read it thoroughly and with some depth, then probably you will get a good idea about the open problems or the problem statement that you may like to choose from that particular paper. So reading 2 or 3 survey papers is actually an absolutely great background to build up. So here are some further tips if you want to proceed this way, if you take this suggestion that I'm asking. Always ask a lot of questions and you keep reading. For example, I use a tool called Journal, which can annotate PDF. So I download a file. I wish I could do it in online with you. Take a PDF document, open it up, and then I can annotate. I can say, why is this question? Why? Okay, I don't agree. Okay, I need to understand why this mathematics, why this term X is doing here. So I can write anything on that, annotate. So that next time when I read, I at least know either answers to some of those questions, or I know whom to ask, where to go and seek the answers. In particular, I would like to, after reading a technical paper, like to get a good idea about the big picture, not the small details. Not that he used a linear equation or some multidimensional optimization. No. What is the problem? What is he trying to solve? And if that problem is solved, how does it change the state of art in any small way? So what application gets affected by the contribution that is mentioned in that article? Now, since it's a survey article, there'll be many contributions. So you would like to get a feel of the big picture that is there in the area. What are the real issues over there? And for that, you need the power of abstraction. If you get merged into details, you will miss the big picture. You will see the small pictures only, the small dots. So what we need to do is to connect the dots in our own way to form a big picture for us, for me. That helps a lot in trying to identify and be precise. It may take time, but do repeated reading of the article till you get the big picture. I wish, we could take a paper and do it in your presence to say what this big picture, how to arrive at a big picture. Extra thing that you will know is who are the prolific researchers, researchers who are continuously working in the area. Which organizations or institutions are doing, significant work in the area. Why is it useful? Because now you can try and make contacts with them with definite pointed questions. The chances are that they will respond back because you have read their papers carefully. Okay, so if you just say, I want to work with you, nobody is interested. But if you can point out a variation or you point out some suggestion in a research paper written by somebody, or ask a deep question which makes that person think, the chances are that they will like to interact with you. So getting to know the good researchers, getting to know the specialized labs or groups which are working is a very good way to start building contacts with the external world. As you read, you will also observe that there are a lot of gaps in our knowledge. For example, if I start reading ML articles today, it's not my primary area, I will have a lot of difficulties. Okay, so I would like to figure out after reading, as I keep writing, as I keep reading, I keep noting, okay, it looks like I need to know linear algebra. It looks like I need to know polyhedral optimization, whatever they are using. I need to know some concepts which are not there with me. So I keep noting down what are the prerequisites which are required for understanding a technical area, which is a survey article, which means a whole area or a sub area. I also figured out what are the analytical mathematical skills which are coming again and again. Okay, so the skills will not be a full course. It may be a few combinatorial aspects in discrete maths, maybe some automata from automata theory, maybe some algorithm issues from algorithms course, okay, maybe something from vector calculus, so on and so forth. So I would like to understand what are the statistical or mathematical or analytical skills which are being used by this area. It's very important to know that. Also, what experimental skills are expected? Which language, which tools, which software? Do I have the source code for that? So once I ask these questions and try and getting the answers, I prepared myself well to initiate my research. Not only that, if I figured out what these are, I can prepare small modules if I am a faculty and start inducting students by training them through these short modules, maybe 4 or 5 lectures. Not great, not big ones, not a full course. Nobody has time for that. So this will be my way or my suggestion in order to start research in a new area, or for a research scholar who is begin trying to figure out an area for doing research. Okay, and as I showed you in the previous one, most of these, as you can see, are emerging areas. They are either in IoT or security or the areas that I talked about. And maybe in a month or two, you will get a good feel of what people have done in that area. And once you get that, you will probably, as you keep looking deeper, you will be able to identify some problem statements which your guide or other faculty can help you evaluate and say whether it is worth the PhD problem or not. So this was one track. Now I'm going to go into some generic research issues, because computer science and engineering is not outside of the general issues or problems when faced with research. So here are some examples. As I said, I love examples. So this example is from Alice in Wonderland. Okay. So the question we are asking to myself is, why research? Why should I do research? What do I get? I don't see any value in doing research. Just because my institute or director wants me, I don't want to do research. So we are trying to bring some other aspects which are very, very intellectual, different kind than a research which is done to satisfy us basic needs for promotion or whatever. So Alice in this, in Alice in Wonderland, she has a lot of adventures in looking when Lewis Carroll is talking about look through the looking glass. He's supposed to be the queen who is here, and behind her is Alice. You can see her face a little bit. So this is the dialogue between them. Well, in our country, said Alice, you generally get to somewhere else if you ran very fast for a long time, as we have been doing. So they were actually running for a long time, the Queen and Alice. So this is what Alice says, we have been running, so we should go somewhere. We should reach some place. And look at the Queen's response. A slow sort of country. Here, in her place where she's, where they are moving or running, it takes all the running you can do to keep in the same place. So you have to do a lot of running to just become stationary in the place without any movement. If you want to get somewhere else, you must run at least twice as fast as that. So this is the interesting analogy with research. Okay. So basically, if you want to, you have reached a certain level of maturity, and therefore you want to retain that maturity, but the world is changing. A lot of researchers are adding material. To retain that maturity, you have to continuously update yourself at a certain pace, which is pretty fast. Read lots of papers, talk to people, and so on. And if you want to contribute something, then you have to probably be even faster than that. So you have to not only consume, but you have to create while other people are working along. So this is the way I look at it by drawing a parallel to research. So for us, for people who are in the academia or who are in engineering industries, there isn't much choice because we have to survive in a world in which there are rapid developments in technology. For me, the change has been extremely rapid, but even for you young people, you can see the changes that are happening, which is keeping us on our toes. You just can't afford not to be at par with the current technology because that's what we will get. So every time there's a new learning taking place. If you buy a new mobile, you have to do something. A new car, you have to again learn something more. So the first line is that we have to run twice as fast. This is only a figurative speech. You have to run quite fast to remain in the same place. The level of maturity or the level of skills that I have also need to be upgraded continuously to deliver what we are supposed to, what we are interested in doing. We need a lot of hard technical skills in terms of details. We need a lot of soft skills to be successful. And these are whatever usual stuff which your other professors might have talked to you. We must have our ability to acquire new skills. Nobody is going to train us all our life. Okay, your education is over, maybe a few short-term training programs. So you can go and join them, but that's not the only way to learn. It turns out that self-learning has to be the way in which we have to enhance our skills, our knowledge, our domain expertise. So self-learning is the key now. Unfortunately, in today's world, there are lots of opportunities for self-learning that you are also aware of. Material.
Sir, we can't hear you, sir.
Can you hear me?
Yes,
now?
sir. Yes, sir. Yes, sir. Yes, sir.
Okay. Sorry. I didn't. Since I was looking at the big screen, I had no idea what was happening.
Yes, sir.
Okay. So in terms of research, if you want to do statues, if you wanted to create statues by cutting stones and create a beautiful pieces of art, then first we need some methods and tools. Okay, tools and then how to cut. That is the method. And then if the methods were primitive and it was taking a long time or it was not giving us the precision, then the obvious research will be to improve the methods and the tools. So as different generations of sculptors improved on the methods and tools from the early ages, of course, the immediate side effect would have been the better statues, more beautiful looking or more realistic and whatever. But in turn, because these methods and tools were invented, ultimately the output was better sculptors. In some sense, the spirit of research is the same. Okay, so there's a lot of feedback which goes on. We invent research methods, research tools, we create better products, and sometimes we create better systems which can create those products. Okay, so this is one facet of research which is very, very interesting. Computer science has done. If you want to, for example, know, if I want to give you a similarity from my domain, I can do that. So people started developing first assembly language or machine language programs. Some of us had to do it in the very, very early stages. And then very soon, elsewhere in the world, they said, no, this is not the way. We should have high level languages. And the high level language for that day was Fortran 2. So they will write in Fortran 2. Okay, so that was the tool. And somebody will hand translate it to machine language by some means, and then they will run the program. And soon people realized that this translation process from Fortran to machine or assembly language was so simple or so sort of obvious that one could actually write a compiler which will do the translation. And now later on, the current state of art is, since there are many languages, many machines, we have compilers, or we have compiler generators. To these compiler generators, if you give him a language description, say C or Pascal or Fortran or CUDA or whatever, and you tell that the machine is NVIDIA or Intel's this or some Motorola, whatever processor, then these compiler generators will develop the compiler for the language L for the machine M, and that is the output. So you're creating sculptors in that sense. So you're now creating tools. Okay, there is no such equivalent in operating systems. You still cannot generate an operating system. Okay, there has to be still, a lot of it is written by hand. So there are these kernels which are very carefully crafted, written in high level languages, but done manually. Okay, so this is one similarity. As people understood the methods, understood the tools, eventually they produce better sculptors. So you change the output level altogether from the product to actually something which the product itself is. Now let's look at another theme. So what is research? In the domain of computer science and engineering, you can create a new device. Is that always a research? I'm working in theory. I observe a deep result. I formulate a theorem. Is that research? Somebody had formulated a theorem, could not prove it. Maybe Fermat's last theorem or whatever. I proved that theorem. Have I done research? I've written a very interesting piece of software which beats everybody, or probably was never written before. Is that research? I'm extremely good at repairing. I debug a very complicated error in a software. Have I done research? There was a lot of data. I use some method, maybe just my manual intelligence, and drew some conclusions which were not obvious. Have I done research? So the answer is, research could be any one of them, could involve one or more of them, or depending on the level of work has been done, could be none of them. Okay, so there could be simple development of any of these, which is not research. Whereas just a single one, even partially done, could be actually research. So these are all different facets of research, like the elephant and the blind man story. Okay, so what actually applies, we'll have to see in a given context. So I'll skip this, you can read it later. So we want good ideas and we want significant ideas in order to. So this talks about idea. What is an idea? Here we say that idea is not an isolated thing. Idea comes in a context. And the context in which the idea has come decides its significance. These are all very generic research terms from a philosophical point of view, not necessarily for CSC. And people generally say, those who sort of believe in this, idea is like a missing piece in a puzzle. So you make lots of observations, you are trying to draw, make some sense out of either a piece of data or some observation. It's not coming up. And then suddenly you get some link which sort of explains, if not full, a large part of the puzzle. So these are the things which we typically call an idea. So it says clearly, discovery of an idea completes at least some part of the puzzle, if not full. Usually it is a connection between other ideas. And generally it is believed that the more unlikely is the connection, people would have never thought that this could actually happen, the more beautiful the idea is. So I can give you an example again from my domain. There could be examples, I'm sure there are examples from other domains. If you have heard about the world of parsing in the 1960s, late 50s to 65, 66, even beyond, there were hundreds of parsing methods which were being evolved. What is parsing? There's a grammar, typically a programming language grammar, and there's a piece of program, and the parser has to say whether there is any syntactic error or not. Is it syntactically correct? That's what it does. People tried very complicated methods, table-driven, this, that, operator precedence, Erdely's parser. Now here is this man called Donald Knuth. If you've heard his name, he also invented LaTeX, which many of us use. He's an excellent top-class researcher. So he observed that there's a very strong connection between parser and automata. And he, for the first time, gave the LR parsers, which is a automata-driven parser. So that connection is so beautiful. It explains why parsers work, why is it correct, to what extent, what should be the property of the language for which the parser will work, and so on. So it is a very, very uncommon way, uncommon tool, the idea of an automaton to link with parsing. People never thought that. So it was so beautiful. He gave the paper in 1968, I think. He wrote the theory with full proofs and everything. But it took 10 to 12 years before people could implement it. And if you're familiar with YAC, the tool Lex, they are all built on his ideas of an automaton-based parser. So people are ahead of their time. They're beautiful, they observe, they give the theory, but the implementation takes so much time that people are not able to appreciate what is happening. And that maturity comes much later. Now, towards innovation, this is borrowed from somebody else's, but I liked it, so I'm going to give you. I'm going to describe this. So apparently it looks like there's a sphere of knowledge. The sphere of knowledge is of not of me or you. It's a sphere of knowledge in a certain area or sub-area. There's something that people know. Okay, that sphere. It is multidimensional, typically, entity. So in this sphere of knowledge, suppose I want to do research or you want to do research. So you enter with some initial general learning. into the sphere of knowledge that already exists in a given area or sub-area. So I acquire some initial learning and I try to enter. I want to do research. I keep doing learning. So as I keep learning, my learning, my learning or my knowledge is going up with time. Still general learning. And from general learning, since I've tried and I've understood the problems and I'm getting a better feel, we start concentrating, focusing, and specializing by picking up some particular ideas and taking it at depth. As we do that, something happens. So the whole thing you can actually visualize through these figures, which I borrowed from that publication. So this is a sphere of knowledge. It exists. Many people have contributed to build this first sphere of knowledge. Now here is, let's say, I, as an individual, entered with some general knowledge, which is at the origin a small circle, a small sphere. As I acquire more general knowledge, this sphere slightly increases. This is my or the individual's, knowledge or learning, which is going up as one is consuming more material, reading, understanding. Then as you start focusing and specializing, the sphere is too big. I don't want to cover the whole sphere. There's a lifelong exercise. It may never end because the sphere will keep expanding. So we focus, we specialize. So you can see this small conic-like object which is coming up. So it is going to increase in a small way in a certain direction. You keep specializing more and more and more, you hit the edge of the sphere. That is the edge of the knowledge. And unless we are very distinctly unlucky, but keep pursuing, the chances are we'll slightly cross the boundary and increase the sphere of the understanding in that area. So then we have made significant contribution or some contribution in the area. This is the purpose of research. The method that I was telling you was trying to do the same. There is a sphere of knowledge. I entered the sphere by reading some survey article, good quality survey article. I keep reading the references, the strong references within the survey article. My knowledge keeps on increasing. In the process, I identify some problems and I see that people have not done it very well. So I'm curious. So I specialize. I keep looking for papers in that area or that aspect only. And keep doing. I see that I have a problem in which I have now getting more and more expertise, and I end up contributing in a small way, and I have done research out there. So this is one way of doing research, and this basically everybody goes through it. The shape may not be exactly like this, but eventually, when you feel satisfied, we know that we have done something like this. Increase the body of knowledge in a small little way at least, which was not the same way before. So let me skip this part, you can read. So let's say whether I am from IIT or MIT or from BIT or from an even smaller college, what has God or nature gifted us with? This is our intrinsic thing, which is independent of where I have been educated or what I have been exposed to. So it looks like we all have lots of neurons in our brain. Okay, so that is what probably is the basic unit for intelligence, creation, activity, knowledge, whatever. Now, if you assume WW, the World Wide Web, and assume that it has about 5 billion index pages, these are all assumptions, some numbers. It might actually be a little more today. I don't know. So assuming that there are, for each index page, there are 10 pages, we have about 50 billion pages. Now, assuming that there are 10 links per page, there are about 500 billion links. And this is the World Wide Web viewed as a network. When you come down to the brain, we have around 100 billion neurons. This is true for most of us. Assuming there are 1,000 links per neuron, which is very realistic and is going to be there, we have 100 trillion neuron links in our brain. So we are all wired up from birth with a network that is 200 times as complex as WWW. And these are only representative. Actually, it could be order of magnitude more. So firstly, our capacity, the hardware that is given to us is enough for creating new ideas, for doing innovations. Only thing is that we are willing to use it. It has to be used, which means it has to be exercised. That's a different story. So this is how people say, or the people who work in neural sciences and all say that usually a certain group, some number of neurons fire spontaneously at any given point in time. It's continuously happening. So when they fire continuously, some idea emerges. That's many ideas are wasted because they are sort of casual. But some of the ideas could be triggered by solving a complex science or engineering problem because you are deeply thinking on it and a new idea comes. It could be because you have written a story or a poem, or you have read somebody's story or poem and you want a punchline, which in a very few words describes the real gist of that story or novel or poem. Okay, so you need an idea. You need a very precise, concise description of that. May or may not be simple, and so on. So there are many of these situations could trigger it. But basically, the point is that we should be contemplating, thinking. Okay, if my thinking is not in these directions, the idea will not be for research in my field. And again, people seem to think and believe that idea does not come from a single thought like this. It usually comes in swarms. So it comes in a huge numbers at a time. And more often than not, we are not able to chase those ideas. They come in large numbers and vanish. And if you're not able to hang on to them, they will be lost. I'll skip this. So these are, again, ingredients that we are all endowed with. I'll take maybe 2-3 minutes more and wind up. So the obvious facilitators are these, which are known. So I'll not talk about them. You can read them on the slide. I want to give you some examples where there are non-obvious facilitators. This from research in other disciplines. One is called a slow hunch. I'll give you an example. Another one is called serendipity. And I'll give you an example. These are all ways of doing creative things. These are all ways of creating new ideas, innovation. And sometimes because of errors, unintentional errors. So an example. So slow hunch. Many examples. The eureka moment, for example, what Archimedes got could be one example of that. He was thinking for a long time, and suddenly this idea came that he could figure out whether the crown was made up of real gold or not. Another more accepted example is Darwin's theory of natural selection. So this is quote from the text from where I borrowed it. In his autobiography, he had written that on 28th September 1838, he basically wrote an essay on this. But in evidence shows from his other readings that he actually had seen it about 15 months before, in 1837. So some idea which has been there gestating for a long time is typically known as innovation through slow hunch. The hunch is there, but you're not hanging on to it, and it takes some time before you get to the idea. But you are working on it continuously. Darwin worked on it for a very, very long time. Serendipity, I've given you the example here, the reason why this name came. So this seems to be the characteristics of this kind of innovation is a happy coincidence, a chance meeting. Okay, unexpected connections which are made by B-rods. Often it happens in the dream. Okay, so in dream you see something and that actually turns out to be solution. So one example of this is, as you well know, Kekule's discovery of the structure of benzene. Okay, and it seems that he dreamt of this particular phenomenon. We don't really know how much truth is there, but this looked like, and this structure enabled him to think whether benzene can have it, and he do the discovery. Similarly, apparently for Mendeleev's table, periodic table was turning out to be very difficult to organize. Which unique parameter will you do? And apparently he had a dream in which he visualized it, that atomic weight was the key. If you did it by that, then the table got laid out properly. So this was another way of innovation. Third one is even more interesting, and I like it even more. Error. Unintentional errors committed while trying to solve a problem. So this great back example, 1919, he lived this long. His goal was to create a device to record heartbeat. He wanted to do that, just measure heartbeat. So during the technology of that period, he used a receiver to catch the signals transmitted by heart. And then he will, of course, count it and give you the beat. Unfortunately, there was a wrong connection. A resistor, wrong resistor connected, started simulating the heartbeat. So it did something very different than what it was intended to do because of a genuine error, unintentional, which was committed. And then once he realized that he has got a different phenomenon, he realized that he had invented the basics of a pacemaker, which could simulate the heart. It can happen many times in our research also. While you are deeply thinking of something, okay, we observe that the result that you are intending is not getting, but I may actually have discovered something else. And that opportunity should never be lost or ignored. So if continuously I know that this is what should happen, I have done my experiments properly, I've set up everything nice, but the results are all wrong, implies probably I have discovered some other phenomenon. I have some other explanation which I should and must explore instead of forcibly changing the data. So this is what by and large I wanted to say. So let me, this is the research cycle, very long ramp up time, lot of time to get up. And then there is a high period in which you sort of mature very fast. And then the delivery after a period will slow down. It's called the S curve. I'm going to skip to my last slide now. You can read this. These are interesting, simple material. So these are the essential ingredients for research I've already said. So let me wind up by coming back to this. Okay, so you have to have publications if you want to do this. But if you want to look at the scenario, this is what I picked up from the statistics published in 2018, where research up to 2016 was accounted for fairly meticulously by so this is from NSF. So if you just look at it, these are some data which is not so important, but if you look at it, per 10 lakh, USA publishes about 1200 research articles. European Union publishes 1200, almost the same range. China produces 300. Their population is much higher. Japan is 720 and we are at 83. Okay. So it's clear that we are not a greatly publishing kind of nation. Of late, numbers have changed. Okay. So there is definitely a need to increase our writing capability. Whatever we do, we should publish. So to conclude, basically, I can see that in an engineering institute from which we are coming from, my current one included. We are primarily good UG teaching institutions. These are the problems. Okay, these are the reality. These are the reality check. We can't do much about it. Our strengths are steady pool of UG students every year. Okay, and if you don't use them in our agenda, then we are going to lose out. So what do? We align our BE projects with care in our research interest, work with them hand to hand to make sure that they feel interested and enthused. Okay, look at the other projects we have developed in the recent past, see whether we can continue them and try and get some publication out of it, whether it get published or not. We must write a technical article. Okay. So once you start developing intellectual property, my feeling is that the other things, research funding, publications, patents will come in due course of time. The major thing is to continue working in with the students with whatever limited manpower that we have. Okay, not at a very high pace, but a very steady, sustained way. These are some studies of good research material. I have shown you one in the thing already. Okay, so takeaways are that we are all well endowed. We are all have enough capacity for creativity. It is our own shortfalling that we don't utilize whatever is given to us. So commitment, ownership, diligence are usual attributes for research, and we all have that in plenty. Okay, so these are some good reading material. You can read if you want. I've given you the references, and thanks. I'll stop here. And if there are any questions that you'd like to ask, you can ask me now. What I'll promise is I will bundle this whole material, including the downloaded papers, in the areas that I have noted down, and I'll pass it to Satyajit, who can in turn make it available to you. This talk plus the bundle of papers. Yeah,
Sure.
over to you.
Sir, it was such a pleasure listening to you today, sir. So last 3 years I have known you and I have learned from you, but today was the ultimate, sir. Such a nice.
I use my time. I thought, if there is something to say, I must have something to say. So,
No,
I have to
sir,
articulate, I have to work
very
out.
nice, very nicely. It was eye-opening for anybody who has listened, and I'm sure people must have gained today. I personally have gained a lot. So,
So
thank
basically,
you so much, sir.
my statement is that we are all capable. We are just not
Yes,
focusing
sir.
enough.
Yes, sir.
Things
Yes,
will
sir.
happen.
Yes, sir.
Maybe
Yes, sir.
our institutes will do at a faster rate. That is fine. But we have good resources in terms of human resources,
Yes, sir.
and we
Sure,
must
sir.
utilize them.
Yes, sir. So, anybody has any questions?
Hello.
Farhan,
Yes.
please proceed.
Hello.
Yes, please.
Sir, myself, Dr. B.K. Sharma from VIT
Yes.
Lalpur.
Please.
Sir,
Boliye, sir.
actually, I am working on fuzzy automata theory,
Okay.
basically, theoretical work.
Okay.
Now,
Sure.
I want to collaborate with any other field in CSC or in management.
No. Again, I didn't answer. So you're already working in a certain area and you want to
Yeah.
collaborate?
Yeah.
Okay.
In which area I can collaborate?
Okay, so I think we'll have to really see what are your other interests. Even in fuzzy automata, there are applications, but the applications are fairly deep and non-trivial.
Yeah.
So if you want to move out of the area, I would again, if I was in your place, then I would have probably looked at some of these new emerging areas and see isme kya ho raha hai, what is happening.
Yes, sir.
So look at some technical articles, get a feel, download some software, install, play around with it. So the learning will be useful because maybe I can apply ML for some other problem altogether, or I can use some other new thing, security aspects in something else.
Okay.
So it is good to know the applications which are coming up, which are very hard to solve, And maybe you may find fuzzy automata theory will solve some of them. So you already have your strength. You need a good case study. You need a good platform to launch your skills. That is the best way. As they say, old wine in a new bottle. So hang on to your strength. Find an application which people could not solve earlier, but now you can probably.
Yes, sir.
So there are a lot of problems today hanging around. It'll be nice if some of us put down our heads together and sorted out these problems and presented. It will take some time, but it is worth doing that activity.
Thank you, sir.
Welcome.
Thank you, sir. Farhan, please proceed.
Thank you. Thank you.
Thank you, sir.
Thank you. Okay. See you. Bye.
Thank you.